डिस्कनेक्ट
इंस्टीट्यूशन ऑफ
इको आ रहा है, इको आ रहा है।
कैसे करें?
माइक बंद करो पूरा।
सर माइक बंद करने से नहीं होगा, आप उनको लीव करने बोलिए ना प्लीज सर, रिक्वेस्ट है उनको लीव करने बोलिए। एक सिस्टम में दो ही लोग ज्वाइन, एक ही ज्वाइन कर सकते हैं, दो लोग नहीं कर सकते।
अच्छा लीव, आप लोग लीव कर दीजिए, बाद में ज्वाइन कर लीजिए।
आएगा
वही हम आपको दे
इको
देंगे ना।
सर, आप प्लीज उनको बोलिए
लीव कर दीजिए, लीव करिए, लीव गेट लीव द वेबिनार।
लॉग आउट कर दो।
बाद में हम दे देंगे आपको पासवर्ड। तो ये इसको दबाना, लीव वेबिनार। हाँ इसको जितेंद्र लीव वेबिनार
जोड़ना होगा तो
जो वही लिंक में जाएंगे। Should we go ahead now? There is no echo.
या इट्स
Yes.
परफेक्ट।
Hello.
Perfect,
Perfect.
perfect.
Okay. We are waiting for the minister to join. He will join at any moment. In absentia, we welcome and respected Honorable Minister for Road Transport and Highways, Shri Nitin Jairam Gadkari ji, our President of the Institution of Engineers, Narendra Singh ji, President-elect Dr. Hemant Thakre ji, past presidents, Chairman CVDB Shri VB Singh ji, Chairman Jharkhand State Center C.R. Ranjan ji, Organizing Secretary Shri Surinder Kumar ji, and our Honorary Secretary of Jharkhand State Center Shri Jitendra Singh ji. Engineer Hegde, CEO of Stoop Consultants, who will be delivering the Padma Bhushan Jai Krishna Memorial Lecture. Eminent engineers, council members, and all esteemed attendees. Namaste and a very good morning to all. Civil engineering has been in practice since the beginning of civilization. However, it was only in the year 1747 that it was formalized. It is the oldest branch of engineering, and all other branches are offshoot from it. We have in India a number of ancient civil engineering marvels. I'm just sharing 3 of them with you because they are UNESCO Heritage World Sites. The first one is Rani Ka Vav, which was built in 11th century. It is 65 meters long, 20 meters wide, and 28 meters deep below the ground level. And then we come to the next, that is Kailash Cave. Next slide. Kailash Cave, it is a part of Ellora Caves. It was built in the 8th century. It is a really wonder because all the construction has gone from top to bottom, and it is worth just like any other wonders of the world. Next, that we have Briddhavasara temple, which is in Tamil Nadu. It is 11th century temple, no foundation, and the well, Pranam, Minister Sahab, Namaskar, welcome.
Sir, Namaskar.
It is 66 meter height with no foundation, built with granite, and the granite is not found in that area. It is simply a marvel how this was constructed. The main point, which is that the Viman or the tower above the Sanctum Sanctorum does not cast a shadow even at the noon time. With this, we move forward. The construction industry has traditionally been labor intensive, and mechanization was never resorted to. In those days, the speed of construction was very slow, and generally the projects got delayed, causing cost overruns. With liberalization and globalization, the speed of civil construction has increased many folds. Under the dynamic leadership of our Minister, Honorable Minister, 2.5 kilometer of 4-lane concrete road was completed in 24 hours. And 26 kilometer of single-lane bitumen road was completed in 21 hours. Another example was of Instacon Tower in Mohali, Punjab. A 10-story building was completed in 48 hours in 2012. India's economy is likely to grow 2.5 times to $7 trillion by 2030, making India the world's 3rd largest economy. For this, a much improved infrastructure is required. The Sagarmala project, Bharatmala Pariyojana are programs for development of infrastructure. Our Prime Minister has recently launched National Master Plan Gati Shakti to connect the economic zones. A large-scale migration has been witnessed in the urban sector. In order to meet the growing needs, the government has launched the Pradhan Mantri Awas Yojana and affordable housing schemes. All these have put increased pressure on the construction industry, forcing them to think on mechanization and generating innovative ideas to meet the demand. Civil engineers in India are not lagging behind. They have come out with several projects which are to be noticed by the entire engineering fraternity in the world. I am citing two examples. One is the Chenab Bridge project, which is the world's highest bridge. It is 359 meters in height, 1.32 kilometers long, and the arch is of 467 meters. It was built by Afcons and Shapoorji Pullenji. Then we come to the next important project, civil engineering project Marvel, that is underwater tunnel below Ganga or Hooghly in Calcutta for the metro. It is 10.8 kilometers long, 5.5 meters in diameter, again built by Afcons and ITD Cementation joint venture. Technology is perhaps the greatest agent of change, and it is evolving at an ever accelerating pace. And there is a need to develop innovative technologies which will reduce costs, save natural resources, protect environment, and help improve quality of life. In future, we have to look for self-healing concrete, thermal bridging, photovoltaic gas, kinetic footfall, kinetic roads, predictive software 3D modeling, modular construction, plastic roads, green roof systems. Keeping in mind the national agenda, the theme of the 36th National Convention of Civil Engineers was chosen as innovation, mechanization, and modern techniques in civil engineering. It is hoped that the deliberations over the today and tomorrow will help the planners to meet the requirements for India to achieve its goal of 7 trillion economy. And with this introduction to the theme, I would now like to invite Chairman Jharkhand State Center to deliver his welcome address.
Namaskar, sir. Respected Chief Guest of 36th National Civil Convention and Conference, Honorable Minister Shri Nitin Jairam Gadkari, President Institution of Engineers, Engineer Narendra Singh, President Institution of Engineers elect Dr. H.O. Thackeray, Chairman Civil Division Board, Engineer V.V. Singh, Convener of the program, Chairman BOG STF, Institution of Engineers, Engineer A.K. Saxena, Honorary Secretary, Engineer Jitendra Kumar, and all the participants. First of all, I welcome to most dynamic, visionary, and innovative Chief Guest, Honorable Union Minister, Road Transport and Highways, Shri Nitin Jairam Gadkari ji with folded hands. I welcome to President, Institution of Engineers, Engineer Narendra Singh, and young and energetic President-elect, Dr. H.O. Thackeray. I also welcome to Chairman CVDB, Engineer V.V. Singh, Convener, Engineer A.K. Saxena, Honorary Secretary, Engineer Jitendra Kumar, Engineer V.N. Hegde, who will deliver Padma Bhushan Dr. Jayakrishna Memorial Lecture. I also welcome all paper presenters and participants. This is the second occasion that the Jharkhand State Center is organizing a national convention under Civil Engineering Division. Earlier, we had organized in 2003 with the theme Role of Civil Engineers, Elevation of Poverty. The development process impinges upon quality, cost, optimum time, and safety. Technology is perhaps the greatest agent of change in the today's world. While never without risk, technological breakthrough promise innovative solution to the today's challenges. Technology is evolving at an ever accelerating pace and there is a need to develop the innovative technological which will reduce cost, save natural resources, protect environment, and help improve the quality of life. India's economy is likely to grow 2.5 times $7 trillion by 2030, making India the world's third largest economy. For this, a much improved infrastructure is required. Our Prime Minister has launched National Master Plan Gati Shakti to get the country's economic zones and would lay the foundation for economic growth over the next 25 years. The Bharatmala Pariyojana is new umbrella program for the highway sector that focus on the optimizing efficiency of freight and passenger movement across the country by bridging critical infrastructure gaps through effective interventions like development of economics corridors, inter-corridors, feeder routes, national corridors, efficiency improvement, border and international connectivity road, coastal and port connectivity roads, and greenfield expressway. Larger scale migration has accordingly been witnessed in the urban sector in order to meet the growing needs of built-up space infrastructure for rapidly increasingly population. Larger scale construction has been taking place in the country. All this has put increased pressure on the civil engineers, construction industry, forcing them to think of mechanization and generating innovative ideas to meet the demand. Mechanization using construction plant and equipment are starting from hand-held tools to large machines like excavator, concrete plants, lift, tower cranes are contributing towards the improvement in the productivity, quality reduction in time of the construction, safety, etc. With the above in mind, the theme and title of the Civil Convention 2021 has been chosen as Innovation, Mechanization, and Modern Techniques in the Civil Engineering. The convention is being organized on a virtual platform and will spread over 2 days. After this inaugural session, we will have Padma Bhushan Dr. Jayakrishna Memorial Lecture that will be delivered by Engineer V.N. Hegde, Chief Executive Officer of Stoop Consulting Private Limited. We have 18 papers to be presented by eminent personality in the field of civil engineering. The convention will be concluded with the valedictory session tomorrow. The deliberation will bring out recommendations which will be useful for the planners to achieve our goals. Again, I, sir, welcome to all of you in this 36th National Civil Convention and Conference. Thanks.
Shri V.B. Singh, an eminent and distinguished civil engineer and chairman of the Civil Division Board, who even in pandemic organized several programs for the benefit of engineering fraternity. I invite Shri V.B. Singh ji to come and share his views on the theme.
Thank you, Saxena Saab. Honorable Minister for Road Transport and Highways, Government of India, Shri Nitin Gadkari ji, who has created record in infrastructure development in India. Respected dynamic President of Institution of Engineers, Engineer Narendra Singh ji. Respected President-elect of the Institution of Engineers, a very young and energetic man, Dr. H.O. Thackeray ji. Respected past presidents of the Institution of Engineers, Shri A.K. Saxena ji, Chairman, Board of Governors of Sustainable Development Forum and convener of this program. Council member from the Jharkhand, Engineer Shivanand Rai ji, Chairman, Institution of Engineers, Jharkhand State Center, Engineer Shri Ranjan Kumar Singh ji, and Honorary Secretary, Shri Jiten Kumar ji, and all the members present on this occasion. A very good morning to all of you. I am pleased that after the overcoming shock of the pandemic, the Institution of Engineers Jharkhand State Center is organizing the 36th National Convention of Civil Engineers along with National Conference on Innovation, Mechanization and Modern Techniques in Civil Engineering for 2 days, today and tomorrow. I especially congratulate Engineer Siaranjan Kumar Singh, Chairman of the Jharkhand State Center, for hosting this mega event. Sir, the highways or any construction work require qualified engineers and latest techniques. We at the Institution of Engineers provide both. We not only produce very talented engineers, but also provide them an opportunity to upgrade their technical knowledge simultaneously with their job. For fulfilling these objectives, we are conducting Section A and B examinations since 1928, which is popularly known as AMIE, for the serving technical personnels who earlier could not get an opportunity to complete their engineering degree due to some or the other reason. We also regularly organize seminars, workshops, and refresher courses on latest techniques and innovations in the field of engineering and technology for upgrading the knowledge of the serving graduate engineers. Coming to today's theme, the theme of this convention is very apt in today's context. Nowadays, construction industry is booming in the country. The role of civil engineering is being played to construct buildings using modern techniques, new materials, and energy design approaches using digital technology are part of the innovation in construction industry. There are a few important areas such as self-healing concrete, thermal bridging, photovoltaic glaze, predictive software, etc., which need to be taken into consideration during construction of buildings. Mechanization too plays an important role in construction industry. This saves time and energy. Mechanization enhances the skill of workforce at the sites of construction. It cuts cost and time. Developing nations use primitive technology, whereas the developed ones use more advanced technology. India ever lagged behind the developed nations in adopting advanced technologies in construction because developers do not have enough capital to spare to acquire modern machinery. There are certain advantages of mechanization, for example, economical, quality assurance, safety, less time consuming, and feasibility. If the builders, contractors, developers pay due attention to these aspects, the quality of construction will not be compromised. Before I conclude, I would like to say that the combination of innovation, mechanization, and modern techniques are interlinked to one another. The application of these three key areas will certainly improve the quality of construction in an efficient and economic manner. With these words, I once again thank our chief guest, Mr. Nitin Gadkari Saab, for sparing valuable time out of his busy schedule for us. Thank you, sir. Thank you so much.
We move on further. Dr. Hemant Thackeray, President-elect, started his career in academics and became the youngest Dean, Faculty of Engineering and Technology of Nagpur University. He is a great sports enthusiast. I think he was also a boxing champion in his time in younger days and was president of the Boxing Association of Nagpur. He has been associated with the institution for last 35 years. He was the youngest council member to be elected to the Council of the Institution of Engineers, and he has been elected as president of the Institution of Engineers at the last council meeting held at Lucknow. I now invite Dr. Thackeray to give his address, please.
Thank you, Saxena ji. A very good morning to all. Chief guest of the inaugural function, Honorable Nitin Ji Gadkari, Minister for Road Transport and Highways, Government of India, the Infrastructure Man of India. Respected Narendra Singh Ji, President, Engineer VV Singh Ji, Chairman of Civil Engineering Division Board, Engineer Siaranjan Kumar Singh Ji, Chairman, Jharkhand State Center, Engineer Shivanand Roy, as well as council members, other council members, Engineer A.K. Saxena, Convener, Engineer Surendra Kumar, Organizing Secretary, Engineer Jitendra Kumar, Honorary Secretary of the Jharkhand State Center, distinguished personalities, Hegde Ji, Keynote Speaker, and dear fellow engineers. At the outset, I must compliment the Jharkhand State Center of the Institution of Engineers India for organizing 36th National Convention of Civil Engineers and National Conference on the apt theme, Innovation, Mechanization, and Modern Techniques in Civil Engineering. Special compliments to the center for choosing personality like Nitinji as the chief guest, and I'm proud that I belong to Nagpur, or to be specific, born and brought up in Nagpur, the constituency of Nitinji. I have been observing him as a leader, understanding new technologies, motivating the government as well as private sector to adopt new technologies and projects, and completing the projects within prescribed or before time limit. Construction of infrastructure projects following quality norms using appropriate machines, technologies, and innovations has been part and parcel of his enormous work. He has, to his credit, many out-of-box ideas and is pioneer of many innovations which have been actually implemented. Jal Shakti or Buldhana pattern is one of them, which has changed the economy of villages by rejuvenating water bodies and simultaneously supplying aggregates for highway network. I will take this opportunity and request Honorable Minister to kindly enlighten the audience on the subject if possible in his address. The impact of construction industry is known to have significant effect on the economy and prosperity of the country. The construction industry is progressing at very faster pace and bringing prosperity to the nation and the people. Last decade has witnessed significant shift in civil engineering practices, especially innovations, mechanization, and incorporation of new techniques have contributed significantly. The efforts taken by all concerned have resulted in making the construction industry capable of overcoming the tag of labor-intensive industry. Themes and sub-themes for the national conference are carefully chosen and sufficient enough to make participants aware about the innovations, effective use of mechanization, and creation of appropriate ambience for using new techniques. I hope this national seminar will provide a platform for upgrading civil engineering practices. I am also confident that the proceedings of the conference contain all relevant information and will prove to be a good reference resource for the construction industry in future. It will also serve as a platform for sharing knowledge. I extend my best wishes for the successful organization of the 36th National Convention by the Jharkhand State Center. I call upon all participants to utilize this opportunity in upgrading their knowledge and motivation in adopting of the innovations and technologies in their construction. I also call upon them to give inputs for developing new machineries to industry, development of new technologies in association with engineering institutions and research organizations, and more importantly, spreading knowledge of success stories of adoption on innovations and new technology. And the practical recommendations and the innovative ideas which will be outcome of this conference will be very much appreciated by Ministry of Honorable Chief Guest. I sincerely hope that fruitful outcome of the conference will go a long way to fulfill the mission of IEI regarding knowledge dissemination on the technologies and techniques desired for the betterment and protection of public life. Thanking you all. Thank you.
Moving forward, Engineer Narendra Singh Ji, our president, and is an acclaimed civil engineer and a current president of the Institution of Engineers. He is known for solving innumerable problems arising during project execution and construction stage. His works for rehabilitation of oustees during the construction of Tehri Dam was appreciated by one and all. Based on his experience, he has published a book on the subject which can help the project authorities for rehabilitation and resettlement during their project execution stage. He is also a great promoter of national languages. I now request our President, Engineer Narendra Singh Ji, to deliver his address, please. Unmute.
Hello, audible? I'm audible.
Ji.
Good morning, ladies and gentlemen. I feel honored and privileged to welcome Shri Nitin Jairam Gadkari Ji, Honorable Minister, MORTH, Government of India, and I want to congratulate him from IEI platform for his successful achievement of about 48,000 kilometer road construction as a national highways in our country during his tenure. which is a world record. I welcome Shri Hemant Thakre ji, Vice President of Institution of Engineers, rather President-elect Institution of Engineers, Mr. V.B. Singh, Chairman, Civil Division Board, C.R. Ranjan Singh ji, Chairman, Jharkhand State Center, A.K. Saxena ji, Chairman, SDF, Shri Sianand Rai ji, Council Member, Jitendra Kumar ji, and other fellow engineers. I welcome you on this occasion. Institution of Engineers is the largest professional organization of engineers having 125 state and local centers in India and 6 overseas chapters overseas. Institution was established in 1920 and was coveted with Royal Charter in 1935 by King of England, by virtue of which we are known charter engineer. II has completed 100 years of establishment and entered into the second century for the nation service. The Institution of Engineers functions throughout the professional engineers, academicians, research workers, and it provides the vast era to the technical and value-added professional services to the government. Industries, academia, engineering communities also. In order to fulfill the basic objective, the institution always endeavored and synthesized an amalgam of academic and practical training with the experience. In order to perform better, the institution is a group of professional members of the various engineering divisions according to their qualification, expertise in a particular discipline of engineering. Presently, the institution is functioning through 15 engineering divisions, in which civil division is the largest discipline, which was created in 1954 in the institution. In order to broaden and strengthen the service of the institution to the technical community and public, this division actively encourages various promotional events like lectures, seminar, workshops, and other educational programs. The National Convention of Civil Engineering is also one of the apex technical activity of civil division, which is organized annually at various parts of our country as decided by the Council. This year, 36th National Convention is being hosted by Jharkhand State Center of Institution of Engineers on the theme Innovation, Mechanization, Modern Technique in Civil Engineering, with Association Birla Institute of Technology, Ranchi. The theme is very relevant. I congratulate the organizer. I wish the paper presentation discussion will be very fruitful for the nation development. As a civil engineer, we know that implementing construction work that creates building or any structure is quite complicated and laborious task and requires the use of various type of machine and equipment. Technology for building and highway construction are still being developed and implemented to the limit of the people hard work and improve the work efficiency. New opportunities for innovative construction at site include the computerization of technical process and construction management for projects. Nowadays, mechanization is important process for working at a large scale with machinery. In civil engineering, mechanization has always been very advantageous in the field of economy, quality, safety, and speedy work. The construction is also become feasible to get the larger outcome. Civil engineering is the oldest engineering and known as the mother of all branches. I sincerely believe that to fulfill dream of developed India, engineering and technology are the key factor. I hope that the institution of engineer, which is the largest professional body of engineers and technology in our country, have a crucial role to play towards the furtherance of engineering profession and overall development of our country. Ladies and gentlemen, in year 1920, population of India was only 25 crore. But today, the population has gone more than 135 crore and which is increasing day by day, while our resources are continuously decreasing. However, due to the huge population of the country, the viable resources seems to be insufficient for the survival of mankind. We engineers have to provocate and self-motivated to accept the present challenges and come forward to design most economical and viable technology to generate employment, enhance skill and entrepreneurship in every walk of life. India has progressed tremendously in 21st century in the field of highways and agriculture sector, construction and real estate sector, textile industry, information technology, telecom industry, automobile industry, mining sectors, etc. In our country, a large population live in the villages and there is a need of specific technology of innovation for rural areas. Our one innovation that made the difference about 3 decades back was the replacement
So we are not able to hear him. I guess उनका internet गया है. Please check it. So we are not able to hear him. Please check whether his internet has gone, I guess.
Should we? आ गया.
नहीं आ रहा है, नहीं आ रहा है.
I think there's a link failure with the president. We should move forward and request our honorable minister, Shri Nitin Gadkari ji, who is a postgraduate in commerce with a degree in law, but better known for his works in the area of engineering. His colleagues in the ministry admire his innovation and engineering skills. And there are several videos on the YouTube giving details of his innovative ideas and cost-cutting techniques. He is the champion of using ethanol, promoting ethanol. We get less dependence on the petrol from import of petrol. He has set up a center for developing technologies and techniques at IIT Madras. I would now request IE headquarters to play a film giving the details of innovative work carried out under his guidance. Please show the film, please.
There are followers.
Wait, we are sharing this film.
There are leaders, and then there are visionary. Taking people and society to where they ought to be rather than where they want to be is what separates
Sir, wait, we are sharing the screen.
There are followers, there are leaders, and then there are visionary. Taking people and society to where they ought to be rather than where they want to be is what separates a visionary from a mere leader. This rare quality is what sets apart Nitin Gadkari, Minister of Road Transport and Highways, from many of his ilk. Born in 1957 into a free-thinking agricultural family, Nitin Gadkari at heart has always been a social worker inspired by the RSS founder KB Hedgewar's ideals of humanity and nation building. Taking off as a Minister of the Public Works Department in 1995, Nitin Gadkari made groundbreaking changes in the speed the city of Mumbai travel. So impressed was the then PM Atal Bihari Vajpayee ji with Gadkari ji's performance as PWD minister that he offered him a responsibility of weaving road nets in the whole of rural India. The outstanding Swarnim Chaturbhuj Yojana, of which Shri Gadkari ji was the chairman, is the culmination of these efforts. 55 flyovers dotting the city have made commuting in Mumbai much easier than ever before. The foundation for the magnificent Bandra-Worli Sea Link was also readied during this time. The jewel in the crown of Maharashtra, India's first expressway, the world-class Pune-Mumbai Expressway, is also a futuristic project imagined and brought to fruition by Nitin Gadkari. Connecting over 13,000 unconnected villages with an all-weather $100 million project is another feat accomplished by this far-sighted visionary. Nagpur, his hometown, has seen first of its kind double-decker bridge. An innovative beautification of flyover using local artists and painting of great political and social leaders was added attraction. Ajni Intermodal Station will have connectivity between long-distance buses, city buses, railways, metro and indirect link with city airport. Nagpur Broad Gauge Metro, which is a commuter rail project planned for Nagpur city and extending up to adjacent areas of Wardha, Narkhed, Ramtek, Bhandara and Chhindwara. World-class institutions like IIT, IIM and AIIMS emerge and thrive under his watchful gaze. This is in addition to the over 1,000 Ekal Vidyalayas that go a long way into molding the future tribal generations. Performing over 10,000 successful heart surgeries is another stupendous achievement in his illustrious career as a warm-hearted do-gooder. The city of Nagpur is the first city to explore alternative biofuels for transport. These include Bio-CNG buses. His innovative idea of India's first of its kind CNG-run tractor has proved to be farmer-friendly, cost-effective and helping in reducing air pollution. In a historic push for biofuels, Gadkari ji is introducing flex engines which will run on 100% ethanol, directly providing additional income to farmers and the agricultural sector. Sanskritik Mahotsav, motivating local artists to go nationally. Krida Mahotsav, supporting local sportsmen to showcase their abilities and motivate them to go nationally and on Olympic level. Projects like AgroVision are helping farmers with latest technologies and practices. His idea of using sewage water for power generation, use of ethanol as fuel have added a whole new dimension to the city's development program. As India's current Minister of Road Transport Highways, he has re-energized the whole sector with his clear vision. With more than 40,000 kilometers of national highways constructed in the last 7 years, 60,000 kilometers of new roads under his supervision are being constructed. The speed of road construction from a mere 3 kilometers in 2014 has grown to 40 kilometers in 2021. The dazzling Delhi-Mumbai Expressway has set 4 new world records with 12,500 cubic meters of concrete being laid down on the 4-lane stretch of 25.4 kilometers. These world records are as follows: highway construction rate at 37 kilometers per hour, construction of 2.5 kilometer long 4-lane concrete road near Vadodara at Delhi-Mumbai Expressway in 24 hours, laying down of 26 kilometer long bitumen road at Solapur-Bijapur section of NH52 in 21 hours. A 50% growth in the length of the national highways in the last 7 years of the NDA government is a monumental achievement. The figures went up from 91,287 kilometers to 1,37,625 kilometers. Going further, INR 3.32 lakh crore is allotted for 22 greenfield expressways, initiated by the bridge building messiah, as he is fondly referred to. Bharatmala and Sagarmala, 2 world-class access-controlled expressway projects led by Nitin Gadkari, are presently in various stages of construction. The Bharatmala project seeks to eliminate the perennial road traffic movement imbroglio across the country. With Nitin Gadkari taking charge, India's much maligned logistics sector has also metamorphosed from a point-to-point model to a hub-and-spoke model. This multimodal transport system integrates railways, highways, inland waterways and airports, conjuring a highly effective transportation grid, substantially reducing logistic costs and pollution. 35 multimodal logistic parks, 50 economic corridors, 10 intermodal stations are being readied for the monumental effort. Logistics summits with the international participants, including government organizations and the World Bank, leading to MOUs worth 2 lakh crore, have been held to add muscle to the initiative. Among his other endeavors, unprecedented progress is evident in port industrialization, national water highway traffic, jetties for coastal tourism, Ganga Yamuna cleaning, fundraising, asset monetization project, toll operate transfer. As MSME Minister, he has gone all the way to promote entrepreneurship, helping rural youth to adopt Khadi as a means of self-employment. The MSME Ministry has also found wings under Mr. Gadkari. He changed the definition for classification of MSME. Now, a company investing 1 crore and earning a turnover of 5 crore will be classified as micro company. The portal Udyam Registration (UR) offers faceless, fully online, paperless and transparent MSME registration process, fully integrated with income tax and GSTN systems. His brainchild, Jal Kranti, Buldhana pattern of water conservation which changed economy of villages by rejuvenating water bodies, has won a global award. Mr. Gadkari introduced the first ever vehicle scrapping policy, which proved to be the fight against pollution and in the interest of road and vehicle safety. New FASTag policy is helping commuters to save their fuel and time on toll plazas. Some of his major work, like unprecedented push for research and development in electric vehicles, leading research and development for usage of waste materials in highway construction to cut down highway construction costs and generate wealth out of waste materials, developing ropeways and funicular railways in the remotest parts of the country, thus boosting tourism. Panchgaon project for women of making carpets from scrap cloth is a classic example of women empowerment. Khadi Prakritik paint, which is made from cow dung, is aiding in employment in rural areas and have exponentially improved rural economy. When all industries were shut in the pandemic, Mr. Gadkari empathized with people by conducting webinars and 800 plus video conferences. His quick decision making in procuring oxygen PPE kits helped those affected by the deadly virus. He generously donated ambulances to NGOs, helped to set up oxygen plants, factory to make remdesivir injections and injections for mucormycosis. Thus, by showcasing strong leadership and taking quick decisions, he handled the COVID situation effectively. His affable nature goes beyond everyday personal equations as he continues to transmit his radiance and ideas to every individual or organization with his unmatched zeal. Gifted with an ability to dream the seemingly impossible dreams and getting them to fruition also defines this clairvoyant visionary. Nitin Gadkari shines on as one of modern India's pioneering leaders and his work a template for the coming generations. If there ever was the infrastructure man of India, he would answer to the name Nitin Jairam Gadkari.
May I request the chief guest, President, Institution of Engineers, President-elect, and all other dignitaries to kindly release the souvenir which has been brought out on this occasion. Okay, नहीं गडकरी जी का तो दिख रहा था। ना, मंत्री जी नहीं है। May I request the Honorable Chief Guest to deliver his address, please.
नमस्कार, श्री नरेंद्र सिंह जी, President IEI. Dr. Hemant Thackeray is my colleague from Nagpur, President-elect of Civil Engineering Association. Shri Vijay Singh, Chairman, Civil Divisional Board. Shri Siaranand Singh, Chairman, State Center. Dr. Shekhar Chandra Datta, Professor, IIT ISM Dhanbad. Shri Jitendra Kumar, Secretary. Shri Ashwini Kumar Saxena, Chairman, SDA. Distinguished dignitaries, invitees, and all my dear friends. I feel privileged to be speaking at the virtual platform of the 36th National Civil Engineering Convention and Conference organized by Jharkhand State Center of the Institution of Engineers, and a well-developed infrastructure is the backbone of the economy for any country. Our government is committed towards holistic and integrated infrastructure growth, and we believe that the development alone can bring about prosperity for the people. I am sure that the discussion through the event on the theme of innovation, mechanization, and modern techniques in civil engineering would be beneficial to civil engineers, researchers, and policymakers toward the development of world-class and sustainable infrastructure in the country. Truly, the civil engineering is a synonym for infrastructure, and it comes from the word civilization. We have a rich, ancient, civilized society, Harappa, where integrated planning and architectures have always inspired civil engineers. We cannot develop society without civil engineering. I would say it is a foundation for all further development, and we need to fulfill the requirement of basic infrastructure towards the affordable housing, clean water, sufficient health ecosystem, education, and accessible mass public transport for our citizens. This is exactly the mission of our government. We have motivation, inspiration, and guiding light in form of great civil engineers and their noble work in the country. The skilled civil engineers are playing a lead role in nation building. Robust road infrastructure is contributing significantly to the socio-economic development in the country. My ministry, along with NHI and NHIDCL, is continuously engaged in nation building. Indian roads are now at par with international standards, and we now hold the world record for the fastest highway construction. The construction rate is now 38 kilometers per day, which is the highest ever in the world. We made a Guinness World Record by building a 2.5 kilometer 4-lane concrete road within 24 hours on the Greenfield Delhi Vadodara Mumbai 8-lane expressway project. We also built a single lane 26 kilometer bitumen road at Solapur Bijapur section just in 21 hours. This is all possible because of the efforts, teamwork, and commitment of our engineers, along with the deployment of advanced construction technology and equipment at project sites. Living with ease is the tendency of the human, and necessity is the mother of invention. Complexities in life are increasing day by day, which call for use of new technologies. Friends, I always say, the innovation, entrepreneurship, science, technology, research, skill, and successful practices, we call it, is a knowledge, and conversion of knowledge into wealth is the future for the country. We are encouraging innovation, research, and technology in shaping the future of construction sector. The technology is changing rapidly across the world, and we should be well aware and keep eye on global technological developments and innovations. We have introduced mechanization, new techniques, and materials in which phase of a road project, such as planning, execution, operation, and maintenance. We are ready to adopt world's best and successful technology and new materials in the construction. The model EPC and HAM contract agreement provide flexibility to the contractors and concessionaires to undertake their own designs and use innovative technology, which improves performance and save the cost. While adopting new technology and materials, social, economical, and environmental viability and impact assessment study are very important at all development stages of the projects. And that is the reason that development at the cost of degradation of ecology and environment is never be accepted. There should be minimum carbon footprints and exploitation of limited natural resources during the construction and operation phase. Being a transport minister, I am committed to adopt an import substitute, cost-effective, pollution-free, and indigenous fuel for the vehicles. This is the need of the time as far as preservation of economy, ecology, and environment is concerned. Further, I am consistently insisting on the operation of construction equipment on clean and green fuel such as ethanol, LNG, bio-CNG, electric, diesel, electric biodiesel. Diesel is a very hazardous and constitutive fuel. JCB company has done a good job by converting its equipment into bio-CNG, and they are getting good export order from Russia. This would bring huge saving to developers and contractors, in addition to benefit for the environment and the health of machine operators and workers at the site. I'm giving you the example. For example, if the contract value is of 1,000 crore, there is a cost on diesel is 100 crore. By using alternative fuel, they can reduce the cost by 50 to 60 crores. So I already requesting the all construction equipment manufacturers that you should make your machinery on the ethanol. Now ethanol is open. Government is giving permission for ethanol pump everywhere. So ethanol is a fuel from the agriculture, and that is the reason that which can be helpful for our agro economy. At the same time, it is pollution free. Then we have already converted our trucks on electric. Now the battery chemistry, we are developing not only lithium ion, but sodium ion, aluminum ion, zinc ion, and we are also proceeding towards green hydrogen. My appeal to all of you that you can make that the use of this sewage water, we can make recycling of water, and by using solar energy, by using electrolyzer, we can make green hydrogen, and we can use this green hydrogen for railway engines, cars, trucks, scooters. Even we can use it for steel, cement, and chemical industry. In place of thermal coal, cooking coal, we can use the alternative as a green hydrogen. And by the cooperation of people like expert engineers like you, we can export green hydrogen to the world. This is a golden opportunity for all of us. We need to reduce the cost and time of construction without compromising quality and sustainability. Friends, I am not a civil engineer, but by experience, practical knowledge, discussion, and self-study, I can understand and give logical suggestions over many of the technical issues and conflicts that come across during any project. I will request you one thing. Now, there is a lot of hesitation in government, particularly the engineers. They are not very much enthusiastic to accept the new technology. This is the time for the engineers to accept the new technology. I'm giving you an example. In Malaysia and Singapore, now it is a very, very good technology. They are now presently in our flyover and ROB and everywhere in the bridge construction. The distance between two piers is maximum 30 meters. But the Malaysia, they have already invented the technology by which they are using the steel fiber in the casting. And particularly the beam is casted in steel fiber by which we can increase the distance between the two piers, not only 30 meters, but we can take it up to 120 meters. And we can reduce the cost of flyovers, metro, and all the type of new transport system by 30 to 40% by using this technology. We can use plastic, rest plastic in the road construction. We can use rubberized bitumen. For example, we can import the vest tire vest, rubber vest from the whole world. And from that wire, we can use for precasting of the beam where we can use that wire. That can be waste to wealth. And the other important thing that rubber powder, we can use in bitumen by making good roads. The soil stabilization is the new technology by which we can reduce the cost. We can make the soil stabilizer in India and we can reduce the road construction cost and we can save our environment. I always keep a positive and time-bound approach in problem solving. I say to fellow officers and engineers that do not break the law, but bend it up to the last limit of the breaking point. Work must go on through a win-win situation for all concerned stakeholders. Common man should not get hampered due to delays in the project. We have adopted the whole life cycle cost approach in building roads. Construction of highways and greenfield alignments is preferred as it reduces the land acquisition cost, avoids displacement of habitation and utility shifting. We are preferring to develop greenfield project, which is an innovative practice towards the huge land cost saving. Preservation of ecology and environment and socio-economic development of a rural, tribal, and backward community is the highest priority. On the line, the ministry has issued direction to all implementing agencies to avoid sanctuaries and national parks and the planning stage and to take alternate or elevated alignment. An excellent example is an elevated stage is on the Nagpur-Jabalpur National Highway, which allow wildlife to comfortably pass without disturbing the natural habitat of the Pench National Park. We are working towards developing more such stretches. The preparation of detailed project report, DPR, is an important phase where technical and quality audits should be taken care at part to avoid any major defects, delays, and litigation in the future. I will request you. My problem, and it is challenging to the all fraternity, the engineering fraternity. Total DPR, the quality of DPR is very poor. And they are not making scientifically and technically DPR. This is a big problem. The DPR makers, where we need to add new quality and good engineers by which we can change the quality of DPR, not for road construction, even for building construction also. And this is the basic thing. Everywhere the poor quality of DPR, we are facing the problem. My request to all engineers who are in the project management consultancy or making DPR, they should use of LIDAR technology is being promoted to speed up DPR preparation with accuracy. The drone technology is being utilized for better surveying and monitoring during the planning and construction phase. Drones can also be widely used for the delivery of construction materials, ready-mix concrete at remote construction sites. The e-tendering system has been processed to bring transparency, speed, and uniformity for the first time, we have included the use of sensor-based technology in the tender process. I will again request you, at a time when I visited Mumbai-Delhi Express Highway, I really impressed by the precast construction work done by Patel Engineering near Vadodara. The quality of work was very good. The all type of the channels we are making for that, particularly for water and other thing, that it was a really a quality of work was excellent. We need to adopt precast technology. I will request to all our engineers that every district there should be 2 or 3 factories for precast, by which we can reduce the pollution, we can improve the quality, and we can reduce the cost. And that is exactly the people like you, your initiative is very important. We are planning to introduce digital construction, a sensor-based construction where the machines will be translate drawing to field, eliminating human interference. We have used machine control technology in the construction of the Lucknow-Kanpur Expressway. The post-construction monitoring with network survey vehicle, NSV, mobile bridge inspection unit, MBIU, is also being done by the executing agencies. This will bring transparency, time saving, and eliminate the human element. Tolling is the necessity of the day. To avoid delays and wastage of fuel at toll plazas, an electronic tolling system has been successfully implemented. The use of simulation and concept design software for project preparation is being adopted for the effective decision-making process and project prioritization. There is a generation of huge quantities of waste from different sources such as domestic, industrial, mining, commercial, construction, demolition activities in our country, and management of waste is a big challenge. Waste material is being utilized like plastic waste, rubber, iron, slag, flash, construction, and demolition waste in road construction. We need to explore or develop appropriate technology for their cost-effective and sustainable use in construction. I'm giving you the example of one engineer, Indian engineer, Mr. Joshi. He's in Australia. He is awarded because he constructed the airstrip by using the steel slag. We have ample steel slag is available in Jharkhand, in Bihar, even in Jamshedpur. Even in all steel industry, the waste is available. That is the steel slag, the quality of the steel slag we can use in place of stone, and we can make our road strong. And it is environment point of view very essential. So everywhere in the ready-mix concrete also you can use that. So somewhere by using in the tunneling process, we get the stone and we can make the sand from that. It is the technology available. We have to protect the environment. And I'm really expect the initiative from the people like you for that. The engineers should work on the principle of optimum use of limited resources and maximum utilization of available assets, where innovation, science, and technology play an important role. Plastic also is a non-degradable material, and which is why it fills in landfills, choking drainage and causing hazards to animals. To encourage the use of waste plastic on national highways, my ministry has issued guidelines for its use within 50-kilometer periphery of urban areas. We have permitted for use of 8% waste plastic in the construction of bitumen roads. The waste plastic has been made the default mode of construction of service roads in all projects in the country. With the proper technology, waste plastic can be used to repair cracks and potholes in bitumen roads. The rubber powder from waste tires, which is very important, can be mixed with the bitumen to form a good quality of durable and skid-resistant pavement surface. And similarly, steel from tires can be used for fiber-reinforced cement concrete. This is very important. This waste steel is available, which is going to reduce the cost, because the steel industry and the cement industry constantly taking the advantage of the situation and raising the rate, which is not in the interest of the nation and in the interest of the industry. We advocate the use of flash in road construction, which is permitted as per the standards and specification given by the IRC codes. The flash bricks have lighter weight, higher strength, and cheaper compared to red bricks. This can be a best environment-friendly material in construction work. Coir and jute are both natural biodegradable plant products. Coir and jute have several applications in road work, such as erosion control of embankment, stabilization, and pavement layers. Coir and jute also promote the growth of new vegetation by absorbing water and preventing the topsoil from drying out. The use of geotextile made from jute and coir improves the drainage and stability of low traffic volume roads, slopes, and embankments, and it will also help poor and rural industries. New technologies like recycled asphalt pavement, polymer modified bitumens, geogrid are also used in highway development, and the cement and steel industries have a monopoly in the market. They hike the prices through cartelization, and we need to minimize the use of cement and steel in construction work. We need to find a sustainable alternative for steel and cement with Malaysian and Singapore technology using steel fibers. We can increase the span length up to 120 meters. This would save the cost of construction to 1/3. Steel from scrap metal will be used for national highway construction as long as it meets the standards required for specific work. The precast technology is also effective in cost and time saving, and we need to standardize various precast components which can be precasted in the manufacturing yard, and they can easily be installed at the site. I'm happy to share with you all that NHAI has been using new technology and materials in the state of Jharkhand. To a large extent, we save the ecology, environment, and natural resources. The new materials used in the state are as fiber reinforcement concrete, 16 metric tons micro silica, 98,000 metric tons and geocomposites, and 2.5 lakh square meter geosynthetics, and 1 lakh square meter geogrid, 6.3 lakh square meter recycled asphalt pavement, and 11,000 metric tons oil slag, and 3.4 lakh metric tons waste plastic for 3 kilometers. Jharkhand is a mineral-rich and industrial state. The cement concrete roads would be better to carry heavy traffic load in the region. In general, cement concrete road have a longer service life, lower maintenance, and higher durability over the bitumen road. There is a need to reduce the construction cost of concrete roads. Cement grouted bitumens mix is suitable in urban areas wherein the water lodging situation arises. This surface minimizes moisture-induced damages, and the maintenance is very less. Micro surfacing is a type of cold mix technology that is most suitable for hill roads and at a high altitudes. I feel very proud to be part of the mega project in India under my tenure, and of course, credit goes to all engineers who work hard to making them unique. Some of them are Bandra-Worli Sea-Link Mumbai-Pune Expressway, first expressway in the country, and 55 flyovers in Mumbai. The Eastern Peripheral Express Highway in Delhi, Chennai-Nasari Tunnel, India's longest 4-lane extra dose bridge on Narmada River in Gujarat, 6-lane cable-stayed bridge on Chambal River in Kota, Rajasthan, and first 14-lane Delhi-Meerut Express Highway, and many other such projects. We are constructing 22 greenfield access control expressways and 35 multimodal logistic park with state-of-art and cutting-edge technology. And this mega project would improve ease of travel and bring logistic costs below 10% of nation's GDP. Upcoming Delhi-Mumbai Greenfield Expressway will be the first longest expressway in Asia to have animal overpasses. It will also have 8-meter tail boundary walls and dedicated sound barriers to increase the safety of animals. The expressway will also have a 8-lane tunnel through in Mukundara Hill Nation Park in Rajasthan to minimize the impact on wildlife. We have provided 4-meter high steel wall to both sides of National Highway section through Khawasa Sivni Wildlife Sanctuary in Madhya Pradesh, which would absorb light and sound of passing vehicles. NHAI is developing greenfield project in the Jharkhand state, which involves construction of 6-kilometer long extra dosed bridge in River Ganga, and this will be an engineering marvel as very few of such bridges have been constructed in India. We need to think for innovative multi-layer multimodal system designed for transport. which will facilitate separate layer for railway, roadway, and arrangement of helipad and drone taxi services at top. Such as integrated approach would save cost and space requirement by large. By using innovative design and engineering skills, we have constructed a multi-layer transport system with road, flyover, and metro rail bridge in the Nagpur Metro Rail project. This is the first of its kind project in India. Inland Waterway Authority of India is also developing multimodal hub in Sahibganj, which will cater to the industrial needs of larger eastern region of India. We have successfully interlinked water conservation with highway construction known as the Buldana pattern, and 126 lakh cubic meter material was extracted, and which has created 12,605 cubic meter water storage capacity in Maharashtra. This model is also approved by Niti Aayog, which can be implemented particularly in drought locations across the country. The bridge cum barrage structure are being promoted for the dual objective of crossing water bodies and storage of water. Recently, I have inaugurated an emergency landing field for Indian Air Force fighter jets on the national highway in the state of Rajasthan. This is a very innovative project from a strategic point of view, and we are developing such facilities at 19 locations along the national highway across the country. This is a unique example of pavement design that serves both aircraft and vehicular traffic loadings. In my constituency in Nagpur, a metro station is being built, which is the first of its kind in the country, which has been designed as a 20-storied building with trains passing through its fourth floor. All upper floors will be developed as a commercial complex. An innovative step by way of developing floating track slab technology by installing a unique mass spring system, MSS, which will help in mitigation of noise and vibration caused by the metro. We need to develop innovative parking system for vehicles in urban areas. The multi-level underground and satellite parking solutions would be the better alternatives in course of limited land parcels. Ministry has taken tunnel project over rupees 2.5 lakh crore, and many are in the pipeline, particularly in the hilly regions of the country. Today, tunnel of 40 kilometer length are operational, 100 kilometer are under construction, and 150 kilometer are under the DPR stage across the country. We are developing a 14.5 kilometer long state-of-art Zojila tunnel, which will become Asia's longest tunnel, and the world's largest single shaft technology is being used in the tunnel drilling process. By redesigning and remodeling the Zojila project and by utilizing the excavated rock material in the construction of approach roads, we have saved rupees 5,000 crore without any compromise on safety, security, and quality. We can use the same tunnel simultaneously for both vehicles and train passing purposes. Such integrated design can significantly save construction and operation cost. Coordination, research standards, and policy matters in respect of ropeway and other innovative alternative mobility solutions like cable car, funicular rail, road train buses has been allocated to the Ministry of Road Transport and Highways. These modes of integrate with the road network to provide better last mile connectivity. The road safety is an important agenda in my mind, and therefore interchanges and grade separators are being provided wherever required to avoid the conflict of traffic. As an authority, it is our accountability and responsibility toward the safe planning, design, and construction of structures for its users. Now, the first advanced traffic management system will be introduced on Delhi-Agra National Highway by NHAI, which will make the journey of road users safe and comfortable. We are adopting artificial intelligence-based technology to ensure safety on Indian roads, and I have just launched a pilot project in Nagpur city in a continued effort to improve the technology to reduce the cost of construction. MORTH and NHAI have awarded about 30 research projects to various IITs and NITs in the country, the outcome of which will pave the way for road construction with lesser cost, with new technologies, and our government has recently launched rupees 100 lakh crores PM Gati Shakti National Master Plan to further expedite holistic and integrated infra development in the country. This will result in the new employment opportunity for lakhs of civil engineers in the coming years. It has been observed that the civil engineers engaged by contractors and consultants lack the requirement competencies that adversely impact progress, quality, and cost. Hence, capacity building at a large scale is the need of the hour. In the new era, it is expected that a civil engineer should take care of the environmental concerns, road safety aspects, contract management, financial aspect, and project management consultancy. Therefore, he has to upgrade required skill continuously. In addition to professional education, engineers have to acquire skills and need to undergo training on advanced tools and software applications, where the institution of engineers can play the role of mentorship for shaping building civil engineers. I always quote American President John F. Kennedy's that he said that American roads are not good because America is rich, but America is rich because American roads are good. It is expected from the construction industry to focus on higher order quality in infrastructure development so that the service life of structures is enhanced and government can get value for the money. I would like to take this opportunity to request you to share your ideas and suggestions to further increase the pace of infra development in the country. With these words, I am thankful to the Institutional of Engineers, Jharkhand State Center for inviting me and providing me this platform to share my views with the civil engineering fraternity. I wish you all the success in every task you undertake in building new India, and either it is building construction, road construction, or dams, or any type of construction. Your great contribution is giving a great progress and development for the country. The role of engineers in the development of the country is very important, very historical, and revolutionary. Sometimes many people giving me the credit for my good work, but that is not my credit, and that is the credit of the engineers who are working with me day and night. I always telling to the people that at the management point of view, we need to build the team. And I am giving the example of mathematics to the people that A person works A square and B person works the B square. The total work is A square plus B square. But when A and B comes together, thinks together and works together, the result is A square plus B square plus twice AB. And this twice AB is a 100% result of collective team spirit. So being an expert in engineering, this is not sufficient. You have to develop managerial skill. You have to develop the IT, particularly related with the engineering. You have to develop the dealing with the people. You have to inspire and motivate your colleagues. And exactly, you have to make your effective management, time management for construction is equally important. Delays are really facing big problem. We are facing a lot of consequences because of that. It is the time for the people that we should be transparent, time bound, result oriented, quality conscious, and corruption free, and 100% committed for the good quality. And that is the time that we need to build new India. And that is the dream of our Prime Minister, to make India Atmanirbhar Bharat, where we need to increase our export and reduce our imports. To accepting the new technology, we can be economically strong in the world. And that is the time we need a correct and appropriate vision for 50 years of our nation, where we can make India super economic power. And exactly that is my appeal to all of you, that you are the architects of new India. And I know that with taking this responsibility, you can 100% going to contribute for the country, for the society. I'm giving my all special best wishes to all of you, giving thanks to you, and giving opportunity for me for expressing my thoughts with you. Thank you very much. Namaskar. Bharat Mata ki Jai.
बहुत बहुत धन्यवाद. Thank you very much, sir, for your wonderful thought-provoking address. And I hope that we will rise to the occasion and contribute to the national program and building a Atmanirbhar Bharat. Moving forward, coming to felicitation of eminent engineers. Sir, we have a tradition that at any convention, we honor, civil convention, we honor four eminent persons who have contributed in the field of civil engineering. Two are from the host center state and two are from other parts of the country. So this year, we start from the host center. The first is, it's a very long citation, but I will read only a few lines. Shri Shivanand Roy, after graduation in civil engineering, started his career in the irrigation department of government of Bihar and rose to the position of engineer-in-chief. He has been involved in planning, monitoring, flood controlling, and various aspects related to dams and irrigation. In recognition of his valuable contribution in the field of civil engineering, the Institution of Engineers India feels honored to felicitate Engineer Shivanand Roy as an eminent engineering personality on this auspicious occasion of the 36th National Convention of Civil Engineers held during October 23rd, 24th, 2021 on virtual mode at Ranchi. Sir, Shri Shivanand Roy ji. Coming to the next eminent personality,
Sir, can you
Engineer Sharad
give me
Jaipuriar,
permission to go?
who has during his distinguished career has been associated with the construction of dams,
Saxena sir.
second launch pad of
Saxena
ISRO.
sir.
He was at site, various civil works related to steel plants, maybe the biggest foundations, infrastructure projects like IIM Indore, IIT Indore, and a number of more. So in recognition of his valuable contribution in the field of civil engineering, the Institution of Engineers feels honored to facilitate Engineer Sharad Jaipuriar as an eminent engineering personality on this auspicious occasion of the 36th National Convention of Civil Engineers held during October 23-24, 2021 at Ranchi. The third personality, eminent engineer, is Engineer YP Gupta. Dr. YP Gupta, a renowned educationist in the field of civil engineering. He has taught in India and abroad, and he has set up a Kumaon Technological Institute at Dwarahat, Uttarakhand. His area of specialization is concrete technology, and he has been awarded Lifetime Achievement Award by the Indian Concrete Institute, Chennai. At present, he is chairman of an NGO, Yash Krishi Takneek Evam Vigyan Kendra, Allahabad, carrying out organic farming. In recognition of his valuable contribution in the field of civil engineering, the Institution of Engineers India feels honored to felicitate Dr. YP Gupta as an eminent engineering personality on this auspicious occasion of the 36th National Convention of Civil Engineers held during October 23-24, 2021 at Ranchi. And coming to the fourth engineering personality, that is Engineer Gyan Ranjan Pal, who was responsible for design, investigation, planning, construction of irrigation works and hydroelectric projects, river intakes. He superannuated as Chief Engineer, Central Design Directorate, Irrigation Department, Government of Uttar Pradesh. In recognition of his valuable contribution in the field of civil engineering, the Institution of Engineers India feels honored as an eminent engineering personality on this auspicious occasion of the 36th National Convention of Civil Engineers held during October 23-24, 2021 at Ranchi. With this, we are over with felicitation of eminent engineers. Now, I would request the chairman, Jharkhand State Center, to present mementos to the dignitaries. First of all, he would like to present the memento to the chief guest, Honorable Minister Shri Nitish Gadkari ji. Followed by next is for our President, Engineer Narinder Singh ji. Followed by our President-elect, Dr. Hemant Thakre. And to our Chairman, Civil Engineering Division Board, Shri V.B. Singh. To conclude the inaugural session, I would request Engineer Jitinder Kumar, Honorary Secretary of the Jharkhand State Center, to propose the vote of thanks.
Very good morning to our dynamic respected chief guest, Honorable Minister Government of India, Shri Nitin Gadkari Sahab, Engineer Narinder Singh, President, Institution Engineer, Engineer Thakre, President, Elect, Institution Engineer, Engineer Mr. V.B. Singh, Chairman, CVDB, Engineer Mr. E.K. Saxena, Chairman, SCF, Shri Ranjan Singh, Chairman, Jharkhand State Center, past Chairman, Secretary of Supreme Engineer, members of First of all, my congratulations on 36th National Civil Convention and Conference. It is my privilege to offer vote of thanks on this occasion. It is the pride moment for institution meeting here that most dynamic Honorable Minister Mr. Nitin Gadkari Sahab has kindly graced the 26th National Civil Convention Conference as chief guest. Thank you very much for your time.
Sir, you are not audible, sir. Sir, you have muted yourself. Kindly unmute. Sir, kindly unmute yourself.
My thanks to Sri Anand Rai Sahib, Mr. Rajpat Ji, Mr. Alam, Chairman elect Jharkhand State Center, Sri Manoj Kumar, Secretary elect Jharkhand State Center, and our past chairman, already secretaries of engineer members, without whom this institution cannot think of. My thanks to Engineer Surinder Kumar, organizing secretary, also for his remarkable planning to make the program success. At last, not least, my congratulations to Sri Engineer Sivanand Rai, Engineer Priyar Ji, Dr. Y.P. Gupta, and Engineer Ranjan Pal for facilitation as eminent engineer personality. Thank you once again to all of you. Thank you. Jai Hind.
Thank you, Jitendra ji. Now, with the concluding of this session, we will break for 5 minutes. After the national anthem, we will break for 5 minutes. And our request, Shri Surinder Kumar ji, to take over from there for the memorial lecture. Instead of 15 minutes break, we will have just 2 or 3 minutes break so that we can make up for the lost time. We request all of you to stand up for the national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उत्कल जलधि तरंगा तब शुभ नाम शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 जय
This session is closed and we will start in next 2-3 minutes. Headquarters will play. I kindly take.
सर आपको लिंक आपको याद है नाम आएगा ना अनम्यूट कीजिए, अनम्यूट।
Mr. Surendra Kumar, kindly unmute yourself.
Okay.
Sir, there is interference. Kindly switch off other devices.
Okay. Sorry for disturbance. Due to link problem, I couldn't connect. I am speaking about Professor Jai Krishna Memorial Lecture. Professor Jai Krishna, born in 1912, had a brilliant academic career, including bachelor degree in science from Agra University, civil engineering from Thompson College, Roorkee, and doctorate degree from University of London. He studied earthquake engineering at California Institute of Technology, USA. Professor Krishna has served as a professor emeritus in earthquake engineering department, University of Roorkee. He was a pioneer in the field of earthquake engineering and established a school for training and research in this field at the University of Roorkee. He provided technical assistance in the country's major engineering projects in earthquake resistant design of structure and equipments. He was the president of International Association for Earthquake Engineering for 4 years, founder president, National Academy of Engineering, and president of the Institution of Engineers, India. He was conferred honors doctorate by the 3 universities, including University of Roorkee. He was the consultant to major river valley projects, particularly Koyna Tehri and Narmada dams. He was author of a very popular book on reinforced concrete and a book on earthquake engineering. Professor Krishna was focused on the development of method of strengthening engineering structures against earthquake forces. Some of his contributions include evolution of simple methods of strengthening building, bridges, water towers, dams, etc. Design, fabrication, and installation of seismic instruments, and evolution of concept of ISO acceleration studies relating to seismic energy distribution. Method evolved for common brick and stone buildings to resist earthquake have been widely adopted in India and abroad. Professor Krishna leadership have been availed by the Indian Standard Organization in preparing codes of practices relating to earthquake resistance construction and by the International Association of Earthquake Engineering in the preparation of guidelines for seismic zoning of countries and determining fundamental design parameters. For his services to earthquake engineering studies, he was awarded recognition at the International Conference at Tokyo in the year 1988. He presided over the world body during 1977-80 and assisted UNESCO in developing seismological studies in different areas. He was elected as a legend in earthquake engineering at the World Conference on Earthquake Engineering held in China in the year 2008. President of India honored him with Padma Bhushan in 1972, and he received Bhatnagar Award, National Design Award, Khosla Award, Modgil Award, Thompson Prize, Kotley Gold Medal, Caldecott Relay Memorial Gold Medal for his scholarship and research attainments. Professor Krishna's contribution to engineering span over 6 decades. In recognition of his life and contribution of engineering, the National Academy of Engineering conferred on him its Lifetime Achievement Award on 10th anniversary of establishment of the Academy. A fatherly figure to the engineering community, Professor Jai Krishna lived a full and illustrious life from 1912 to 1999. In memory of his dedicated services, the Institution of Engineers India instituted an annual memorial lecture in his name during the National Convention of Civil Engineers. In memory of his dedicated services, the Institution of Engineers India instituted an annual memorial lecture in his name during the National Convention of Civil Engineers. Thank you.
Now I request Engineer V.N. Hegde, Chief Executive Officer, Astup Consultant Private Limited, who is internationally renowned and eminent personality.
I think there seems to be some problem. I'm not able to hear. Right?
Sir, we can hear you.
He has finished his introduction, right?
Yes, sir. Sir, do you have any presentation?
Yes, I have a presentation.
Okay, sir. So you
Yeah.
can share your screen, sir.
I think I'd already screened, but somehow. Can you see the screen now?
Yes.
Yeah,
Yes, sir. We can see.
my screen is shared. Okay, thank you very much. Can I start, Dr. Thakre as well as Shyaranjan? Can I start my presentation? Hello, all of you can hear me?
Yes, sir. We can hear you. You can
Yeah.
start your presentation, sir.
Thank you very
Please.
much, and thank you very much for inviting me to give this very prestigious Padma Bhushan Jai Krishna Memorial lecture. In fact, after having heard Nitin Jairam Gadkari during his inauguration, which was an inaugurating speech indeed, and also the introduction of Jai Krishna, Professor Jai Krishna, and I'm really, honored and privileged to be giving this lecture here today to the August gathering of the Institution of Engineering, Civil Engineering Fraternity. In fact, it was a popular demand by the Institution of Engineers when they contacted me to give this lecture on signature bridge. What I call it is a Namaste bridge. And I was chosen to be delivering this prestigious Padma Bhushan Jai Krishna Memorial Award just because of this signature bridge. That is the popularity of signature which made me to be chosen for this particular prestigious lecture. I'm very grateful for that. And though this particular bridge which I'm going to talk, a very innovative and very of its kind in the world, what I call it as a Namaste bridge, and also which I'm titling my project of the presentation as a My Trust with the Namaste Signature Bridge. That's what my thing is. Many the papers as well as the many presentations have been already made all around the world as well as in India. Just because of the popularity of it and because of the demand of it, I've chosen this particular project for the presentation today for this prestigious memorial bridge. And the bridge is standing as you can see on this the slide over here, and you can see that it looks like a namaste. And this bridge is in Delhi and connecting the west approaches of the Vajirabad to that of the eastern approach of the Vajirabad, which is going towards the Khajura Ghas. And as you can see on this, and on the western approaches, away from this particular bridge at around 600 meters, there is a barrage bridge, which is a very, very congested bridge, and there was a perennial traffic, creating problems for the travelers to travel from the western approach to eastern approach and vice versa. And in view of this, bridge was conceived. And as you can see here, this particular package was consisting of the two packages, this project. One is the signature bridge, which is called as a second package, and the other, on either side of the western approaches as well as the eastern approaches, we had two more projects. That was a contract, which is called the Vajirabad approaches contract. Both this together was amounting to around 1,500 crore rupees. The signature bridge was costing around 900 crore rupees by the completion of at the time of the completion of this bridge, and the approaches were costing around 450 crores. And for these both projects, I was involved from the inception to the completion. As such, I am delivering the lecture as a constructor from the inception to completion, or the commissioning or the inauguration of this bridge today. And this particular area was not only was meant to be easing the traffic from the western approach of the Vajirabad to the eastern approach of the Vajirabad, but also it was to be developed into a tourist attraction. That was the plan way back in 2005 and 2006. And when the bridge was conceived, then the Sheila Dikshit, the chief minister of Delhi at that time, she says, I don't want a run-of-the-mill bridges over here. I want a bridge which is not built anywhere in the world. When this area is developed, this bridge should be the tourist attraction, and the location should be known by this bridge. I want such a bridge at this location, so that not only the area becomes a tourist attraction, but also it has to be known by the very bridge itself, as normally historically happens all over the world, where the location is known by the artifact which has been built. So that is how this bridge was inspired by the leadership of that particular time. Apart from that tenacious leadership inspiration, and this bridge was to be of its kind, and if it was to be a bridge which was not built anywhere in the world, and also it has to reflect the local traditions as well as the cultures. And as you all aware, the Delhi is a like amalgamation of the old architecture, the Mughal architecture as well as the modern architecture, and it hosts many of the monuments. And the tallest monument is the Qutub Minar, and one of the reason for this boldness is to make this pylon of the bridges twice the height of the Qutub Minar, that is around 73 into 2, almost around 145. And also the bridge was to culturally symbolize the Indian culture of the welcoming post Namaste, as you can see here on this. And also the bridge has the national bird, the peacock, the feather on its body, which shows the progressive India. And all this inspirational factors for having done the many of the analysis, as you can see on the right hand side over here, including on the graphics. Ultimately, this Namaste post bridge was conceived and it was to be implemented later. So as a run-up to this bridge, there are many historical moments, as you can see here. One of the moment is the Sheila Dikshit's demand that I want a bridge which is not built anywhere in the world. The second is the bridge, if you really look at it, it is not the conventional form following the forces kind of structural form. In this bridge, form is, following the forced flow of forces, following the the shape of a namaste, the Indian welcoming pose. And also this particular bridge, after many deliberations, was approved by Charles Correa after many deliberations, as I say, and the bridge was tendered 3 times before being awarded finally to the JV. And all this 3 times tendering was done only because the price was found to be higher. And ultimately, when it was referred to the the Metroman of India, Sridharan, who was very active at that particular point of time during the fame of DMRC, Delhi Metro Rail Corporation, he said to the Chief Minister, when she said that it is a very expensive bridge, with the same cost, that twice 2 bridges can be built. He said that the Rolls-Royce, cannot be constructed or bought at the price of the ambassador. So as a run-up to this bridge, there are some historical moments of truth, as I can show you here. Coming to the bridge itself, the bridge is asymmetrical bridge, as you can see here, with a 251-meter clear span, as you can see here on this particular slide over here, and having a shape of namaste, both from the front as well as the back elevation, which is a completed bridge over here, and also from the side elevation, as you can see here. All of you are able to hear, right? There's no issue.
Yes, sir, we can hear you.
Yeah. So I think this, on one side of the bridge, the span is around, the clear span is around 251 meters, as you can see here. This is equivalent to the clear mean span of a cable stay bridge of 502 meters. If equivalent span of 502 meters is the largest span cable stay bridge in India as on date, the another bridge which is going on of the 500-meter span is the Dwarka Bight bridge of its kind, which is going on right now. But even then, if you consider as an equivalent span of one side cantilever of the pylon, 251 meter becomes 502 meter. Even after the construction of Dwarka Bight, this may be the largest span one side cantilever the cable stay bridge in India. And I'll come to the explanation of this the composite deck girder later, where I'm going to explain the fabrication as well as the erection of this one. Let me explain about the foundation and substructure aspect of this particular bridge. And this bridge had 35.2 meter cross section, and 35.2 meter cross section was catering for 8 lanes of traffic in each 4 lanes in each direction. And the foundations were in 2 independent posts, as you can see here. And there were around 3 into 2, that's a 6 number of open foundation. What I call it's a deep open foundation. Though it's an open foundation, it's called the deep open foundation. And also around 16 number of well foundations, as you can see here. Out of this 16 number of well foundation, 2 were hybrid foundations, which I'm going to explain. That is a very innovative design and construction of this foundation. Is a hallmark of this bridge, which I'm going to explain later. Of course, it has the 2 plane of cables on towards the reverse side of the bridge, of having 15 into 2 numbers, 2 plane, each having the 15 cables. On the other side, around 8 numbers of the cables, 2 planes of 4 numbers. So total number of cables of 38 numbers. And the explanation of the cables I'm going to give later during the explanation of the bridge itself. So that you can see the photograph over here, the construction of the the foundations in the 2 independent posts, which is going on over here. It's a Google image which was taken during the construction. And the pylon foundations are called the P19 foundation, which was a very famous foundation. And also the backstage foundation is P23 foundation. Rest of the foundations are the normal conventional well as well as the open foundation. The special foundations were P19 as well as the P23, which is very famous all over the world at this particular point of time. It's very interesting to see the substructure, that is the bearing arrangement within the bridge system over here. It has around 2 fixed bearings at the location of the pylon base and 20 free bearings at a different locations independently, as you can see here, this in this violet color over here. And also the 2 longitudinally guided bearings, as you can see here, and very importantly, a pendulum rocker pendulum bearing at the location of the P23 foundation, which I'm going to explain the significance of significance of it at the later. Out of this, the pylon foundation were the spherical fixed bearing, as you can see over here, of the capacity of 17,100 ton. That's the largest capacity of bearings in India, perhaps. Maybe I think it's the second or third largest capacity bearings in the world, and also a special rocker and pendulum bearing, which is provided in P23 location, because it has to neutralize the uplift force of around 6,380 ton. And this uplift force, because of the peculiar configuration of this bridge, has to be neutralized and ultimately transferred to the founding strata. For that, it has to be provided. And you can see here the rocker pendulum bearing configuration over here. And it's a very significant bearing. And the installation, fabrication, and the erection of this bearing, I'm going to explain in detail. And though the pylon, at the pylon base, we had a two spherical bearing, which is supposed to be fixed, but this spherical bearing has to be, allow a play of around 60 mm on one side during the construction, because of during the construction, the structural behavior makes this pylon, as the load on the pylon goes on increasing, there will be an expansion over here, that the vertical force will give rise to this some sort of a lateral force over here. And during the construction, to make this structure determinate, especially for this, and after the construction is over, during the service condition, this bearing is made fixed. On one side, during the construction, it is fixed. On the other side, the play of around 60 mm is done. So the bearing has to be capable of absorbing 60 mm play during the construction. That way it was to be done. That was one of the specialities of this bridge. Coming to the foundation, there were around 6 number of open foundation, as I explained to you earlier. Out of the 6 number of open foundations, all were deep foundation, varying from 10 to 20, the founding level being 10 to 20 meter depth at the river portion, as well as at the embankment portion. In fact, the P19 foundations, the pylon foundation, were also of the deep open foundation. Various, what I call it as an excavated lateral system in the form of the sheet piling was examined. Some of the variation in the excavated lateral system which were examined were, one is we had 2 independent foundations, as you can see here. Combining these two, one of the options was to have a sheet piling or the copper dam, combining these two, one sheet piling copper dam. Another is to have an independent circular sheet piling copper dam. And ultimately, it was decided to go for all this open foundation, 6 number of the open foundation, to go for an independent square sheet piling copper dam, as you can see here. Though the circular sheet piling would have been economical from the quantity point of view, by the construction point of view, it was very difficult to construct. That's the reason we went for this square type of the sheet piling. These are some of the views of sheet piling is being done. And this deep open foundation sheet piling was done, as you can see here. This is the general methodology of the construction. On the open ground, sheet piling is driven by the vibro hammer, as you can see here. As the excavation keeps on going on, to stabilize the side or the shoring, to provide some sort of a shoring, the strut and veiler system has to be adopted. Depending upon the depth of the sheet piling, the strut and veiler system has to be designed. Number of levels of the strut and veiler system has to be designed. And when the sheet piling cannot be normally done beyond the rock level, and when it reaches the rock level, to make sure that the sheet piles are not sort of a slide, that or some sort of a pin jointed connection has to be established to a design point of view. At the point at the bottom of the sheet piling, specially designed these pins were installed over here. And this is one of the significant contribution of the design over here. Perhaps this kind of pins which was installed, grouted pins within the tubes, and the tube has some sort of a reinforcement or a steel segments, steel segments, as you can see here, ISMB 200 within the 230 mm, and later grouted and provided the stability to the sheet piling which is there later, and you can see that too, and that's how it has been done. And at the location of the pylon, we had, I told you that the deep open foundation was up to the level of the 20 meter, and up to the level of 20 meter, the sheet piling was to be driven earlier, and the open foundation was of around 20 meter, 23 meter dia, and it was varying from the edge thickness of 2.5 meter to the 4.5 meter at the root of the pier, and the pier was around 5.5 meter, and also the height, this pier cap, as you can see here, is 5.5 meter, and this pier cap was supported the independent pylon legs, as you can see here, that I'm going to explain. The pier, as well as the pier cap, is constructed by the conventional shuttering, as you can see here, but for the construction of the open foundation at the bottom at around 20 meter, we had to adopt the sheet piling. As you can, I think there is some disturbance. Sheet piling, and particularly for the P19 foundations. Particularly for the P19 foundations, we had to have the strut and wheeler system at around 4 levels as the excavation proceeded to stabilize the side slopes. As you can see here, naturally, of course, that would have, we had to have the pin arrangement, as I explained earlier, and the vibro hammer was used for driving the sheet piling, as you can see here. Almost around 1,650 cubic meter of the concrete was to be done at one go, which was done in one go. But as it is a mass concreting, and this kind of concreting has to be done at one go, a proper arrangement for chilling or controlling the temperature within the concrete was to be done. And this had around 280 tons of the steel which is embedded into this foundation, and the reinforcement fixing itself of 280 ton at this level took around 40 days for us, and with a lot of precautions, this foundation was done. You can see the brick wall was constructed as a shuttering for this open foundation, which is at around 220 meter below from the ground level. Well designed, well point system was designed for lowering the water table so that the water is not ingressed, water is not seeped into the pit, which has been supported by the sheet piling arrangement over here. And also 35 HP pumps are also used inside the sheet pile coffer dam for the exclusion of the water within that. That's how this open foundations were done. After having done the pylon foundation, it was very necessary for us to install the bearings which has been fabricated in Morasoni and which was inspected for the quality control purpose, was to be installed on top of this pylon pier caps, as you can see here. And these bearings, which was made or which was manufactured in Germany, was brought. It was almost around 26 ton, and the fixed bearing was weighing around 26 ton, and the free bearing was weighing around 16 ton, and it was almost 3 meter in diameter. And these bearings were to be fixed on the bottom plate. As you can see here, this bottom plate is a part of the pier cap over here, and you can see the pier cap and the bearing. Under this, there is a bottom plate. This bottom plate has to become a part of the pier cap on top of it here, and the installation of the bottom plate while casting the pier cap itself was a very project in itself. As you can see here, there is a frame which is hanging the bottom plate of the pier cap over here. Meticulously, the reinforcement of the pier cap has been fixed. After that, the shuttering has been put all around. Once the shuttering is put, the pier cap, the bottom plate is held by this structural frame arrangement which was there. Then the concreting has been done, and you can see the pier cap bottom plate which is ready to receive this bearing over here. The bearing is put on top of this bottom plate, and it is fixed to this bottom plate. Then the base the pylon base of almost weighing around 450 ton is lifted by the 1,250 ton capacity crane and put on top of it. Here you can see the view of pylon base being lowered on the bearings over here, this one. So even the installation of the bearing of 26 ton capacity and also the casting of the pier cap itself required the highly engineering calculations as well as the engineering methods to be adopted in this prestigious bridge. All the well foundations as per the contract conditions were to be done using the jack-down method of sinking, and some of the views of the jack-down method of sinking. I'm sure many of the people who are conversant with the well foundation is aware of the jack-down method of the sinking. Though the jack-down method of sinking was not required, could have reduced the thickness of the staining, it was not done. Jack-down method of sinking was only used for the purpose of controlling tilt and shift during the construction, during the sinking of the wells, but it is not used for reduction of the staining, thereby the economization of the well foundations, as you can see here. Another innovation which was introduced for the well foundation was the micropiling by the contractor's designer here. As per the original design, the well foundation was to be sunk up to the top of the rock by around 500 millimeter. That's around half meter. Once it reaches 0.5 meter above the rock level, well foundation was to be supported on the stools, as you can see here. And the provision of the stools and also the concreting of this insertion of the stools after the well has gone up to there was a risky proposition, because in the water the divers had to be sent, the stool was to be put. It was a highly risky operation. In view of that, the contractor designed this micropiling arrangement through the conduits which has been left of around 230 mm conduit which has been left through this staining. The micropiling was done. This micropiling acted as an enabling structure for enabling the pile the bottom plugging, as you can see here. That is another innovation which was introduced in the sinking as well as the construction of the well foundation over here. Unfortunately, this P23 well foundation, which is a backstay foundation, as you can see here, which has to neutralize, which I explained, of around 6,830 ton vertical load, and very crucial foundation was coming in the forest area over here. In this forest area was only made available to the contractor after 30 to 36 months of the elapsing of the contract period. In fact, this particular foundation, being a very crucial foundation, was coming on the critical path, but it was handed over to the contractor after 36 months. When this was handed over, since in a Yamuna River bridge, there were instances of encounterance of the sloping rock, the contractor decided to do the excavation, the soil investigation, soil boring, or a geotechnical boring around the periphery of the 17.5 meter dia wells, which were spaced, as you can see here. It was having the 17.5 meter dia wells at independent wells, and to the surprise of the designers as well as the contractors and even to the clients, within the diameter of the well of 17 meter, the rock was varying at the almost 9 meter difference was there from one side of the well foundation to the another side. It was varying like this, as you can see here. So the originally designed the well foundation, it was not possible to adopt, because as soon as the well foundation reaches the sloping rock, the well foundation cannot be stable, tilt and shift will occur, plugging of the well foundation is impossible. So the contractor has to come out with a very ingenious way of constructing this. And since the contractor had his own experience of designing, there's a similar kind of encountering the similar kind of situation in other case called the Jogigopa Bridge, and the proposal came from the contractor side to make this foundation as a hybrid foundation of the pile as well as the well foundation, as you can see over here. In this, particular foundation. So contractor had this experience, and for doing this piling inside the rock, actually the RCD boomer rigs were to be imported, and that also took around almost 1 year. So the delay of the project was mainly because the geotechnical investigation was not done during the DPR, as explained by our Nitin Gadkari Saab in his inaugural speech today. If the DPR, during the DPR stage, proper geotechnical investigation or the geomapping was done, perhaps the delay of this project could have been avoided completely. In this particular case, what has been done is through the well foundation, as you can see here, the conduits were left while the sinking of the well. There were around 16 number of 1.2 meter dia piles were proposed. As the well foundation is sunk, the conduits is left within the well staining, and this pile foundation was to be embedded into the rock. The sloping rocks, as you can see here, these are the two independent well foundation, was into the rock by around 6 meter, and this 6 meter was done, and using this RCD rigs, after the well is sunk up to around 0.5 meter above the earliest rock level, which has been sunk, and the piling is done using this RCD rigs. Once the piling, which has been done, which has been embedded into rock by around 6 meter, the bottom plugging is done. After having done the bottom plugging, this particular foundation has to neutralize the uplift of 6,300 ton load, as I explained to you earlier, and we also had the high density concrete of around 3.5 ton per meter cube density, or the specific gravity, what they call it as. That special concrete was to be done to increase the weight of this foundation, and that was done, and that is how this particularly this P23 foundation was completed. These are some of the views, as you can see here on the screen over here. The conduits during the sinking of the well foundation, as you can see here, 16 number of conduits of 1.5 meter, 1.2 meter dia. The conduits was to be 1.3 meter, giving the little bit high inside diameter of this conduits were 1.3 meter. This is the building of the curb along with the conduits, as you can see here, as specified in the contract to control the tilts and shift. The jack-down method of sinking was adopted even for this very crucial foundations. This is constructed up to the top of the well cap. The conduits can be seen over here, through which the piling was to be done. This RCD rig, boomer rig, was mounted on this conduit, which has been kept over here of 1.3 meter. As you can see here, using this RCD rig, reverse circulation drill, what we call it as RCD rig, the piling was done, and after the piling is done, the pile cap within this coffer dam, which has been left over here, was to be done. This is the very peculiar foundation, the substructure, the rocker and rocker pendulum bearing. How the rocker pendulum bearing was conceived to transfer the load of, to take care of the load of 6,300 ton vertical the uplift load, which comes under the critical combination. These are the rocker bearings. These rocker bearings was connected to the 360 number of PT bars. This PT bars was embedded in the piers, as you can see here, and these PT bars, along with the pier as a transformed section, transfers the load to this well cap, which is connecting the two independent well foundation, hybrid foundation in this particular case, a hybrid foundation, a pile as well as the well foundation. This is the pile cap, and this is the 360 number of PT bars of 36 number of diameter, which is in fact pre-stressed, that which I'm going to explain later. And ultimately, whatever the vertical load which is coming will be neutralized by this, the link, the rocker bearing links. These are the rocker bearing link, which is connecting the main girder to that of the 36 PT 320 numbers of PT bars. As you can see here, ultimately this uplift is transferred to the bottom stratum, at the bottom stratum, as you can see here. That is a very ingeniously conceived transfer of uplift force at the backstay cable was done in this particular. casting of the well cap connecting these two well foundations of 17.5 meter itself was a very Herculean task. It was of the side of 42 meter well cap connecting these two well foundation, as you can see here, 16 meter almost around in the transverse direction, and also the thickness of the well cap was around 4.5 meter. And this well cap was to be done, was to be embedded with, as you can see here, 320 number of 360 number 32 dia PT bars, as you can see here. This which has to transfer the uplift force of around 6,380 ton. As you can see here, this was to be very precisely embedded into the well cap, and this well cap concreting was to be done during the cold season, that is around 66 degree during the night time to that of around 17 degree during the daytime. That was the cold reason. When you do the mass concreting of 4.5 meter of around 2,850 cubic meter of the mass concreting for any mass concreting, at the center of this well cap, that is the mass concrete, that's around 2.25 meter, there was around 70 degree heat of hydration which was developed, which was measured, and the difference between this heat of hydration to that of the ambient temperature should not be more than 25 degree. If this is more than 25 degree, there will be cracks developed within the well cap. That was to be ensured. The outside ambient temperature was 6 degree. The inside concrete temperatures which was developed because the heat of hydration was around 70 degree, which was 70 degree was maintained for 5 to 6 days continuously. It was there for 5 to 6 days, and there had to be made a sufficient precautions in the form of the insulation. Here, instead of curing, we have to make sure that the heat of hydration is maintained rather than like it is dissipated, basically, so that the difference between the ambient temperature as well as within the concrete should not be more than 25 degree. So it was a cold weather concreting, basically, which was to be done with a lot of precaution, and all this well cap concreting had to be done at a go. Continuously, the concrete was to be produced for 2,850 cubic meter, which was to be done. It was a very Herculean task indeed. The erection and the launching of the P23 rocker pendulum bearing itself was a very ingenious engineering task, as you can see here. And these bearings, which was again fabricated or made in Germany by Morrisoni, was brought, and as it was not possible to handle this entire bearing set, as you can see here, this is the entire bearing set because of the logistical and transportation and the handleability point of view. This bearings was put on top of the pier cap and embedded first to this PT bars which I was talking about here. Once it is embedded, the meticulous planning for the erection of this independent the girders was done. These girders were erected over here, and it was spliced with each other by way of the bolting. And then once it is bolted, the links were vertically rotated, as you can see over here, and the pins were inserted. And after having done by way of operation of the jacks, which has been provided on top of the temporary trestles over here to the required level, the deck, which was integrated with this deck anchorage assembly, was lifted up, as you can see here. That's how it was done. These are some of the views which was done. The bearing, the rocker pendulum bearing, one part of the rocker pendulum bearing which has been transported to the location. As you can see here, within this, the links were in the sleeping mode over here. After having put the girders on top of the temporary trestles over here, and after bolting it together, these links were vertically put on, vertically rotated upwards, and the pins were inserted. After having inserted all this rocker pendulum bearing, the bottom plate has to be grouted properly, so there's a proper contact between this bearings as well as this one. The another interesting part was this entire superstructure was fabricated, deck as well as the pylon steel in China. The bearings were produced or fabricated in Germany by Morosoni, one part of the bearing, that is the top, the pin holding ring, which is coming in the part of the superstructure, as you can see here, which was to be transported, which was to be sent to China for the fabrication purpose, so that within the deck, this pin has been introduced over here. So the transportation of one part which has to be integrated into the superstructure was logistically a challenging one, which was addressed properly done. I'll come to the superstructure part now, and superstructure is made up of steel, and especially the thickness of the steel was varying from 2.5 mm thick plate to the 250 mm thick plate, and the 250 mm thick plate is a very high plate. In fact, in India, more than 80 mm thick plate was not easily available. That is one of the reasons we had to go all over the world for finding out the contractors, the fabricator who can do the fabrication with very high thickness of the plate, and also the steel is easily available. And the team of the engineers, including the client's engineers, as well as the contractors' engineers, and the designers, took the global trotting, the global world tour. We went to the Netherlands, we went to this Italy, as well as the China, and ultimately the ZTSS in China was chosen as a fabricator for this particular job. And we had the composite deck, which is consisting of the two girders over here, longitudinal beam, as you can see here, and also connected by the cross girder, and also the pylon, which was made up of boxes. The legs was merging into the pylon body at around 60 meters. As you can see here, this is the cross section of the body, which was varying in width from 20 meters at the level of where it was merging to that of around 13 meters where it was ending. After the pylon bodies merging and ending, the glass facade of the viewing gallery was stocked in this one. The pylon legs were in the cross section varying from 2.5 meter into 7.6 meter to the 2.5 meter to 9.6 meter. That was the enormity of the size of the pylon legs for this particular project. And especially for this particular project, the Z quality steel, that's a Z quality steel was used, and Z quality steel is the special quality steel where in the Z direction, normally the steel properties are tested along with the rolling longitudinal direction as well as the transverse direction. Since here, the thickness of the steel, which was to be used even up to the 250 mm, ranging from 2.5 to 250 mm, there was a threat of lamellar tearing. As you can see here, the lamellar tearing is when the welding of the plate is done on top of the existing plate, the another plate, there's a possibility of horizontal cracking which is taking place. For that, along the thickness direction, special quality, the ductile quality is required, and the special fabrication or the manufacturing process has to be adopted by using the sulfur content, reducing the sulfur content. So that is called the Z quality or the Z quality steel. It is one of the projects where the Z quality of the steel is used in India. And also the understanding of the complex structure was very important from the fabrication as well as the trial assembly point of view. Nowadays, BIM has been specified and used extensively, but here it is not the specified, but the BIM was the necessity, as you can see here, to study the complex geometry of the pylon as well as the deck, to work out exact weight of the elements, structural clashes, to plan fabrication as well as trial assemblies, and to plan even the erection sequences. It was very, very essential. It was not only though it was not specified, without the BIM, like Tekla or Revit, this project would not have been completed. So this is one of the Tekla model which you have seen. Have a look at it, how the BIM was very extensively used over here to understand the pylon complex geometry. As you can see here, the pylon base over here, it has got so many internal diaphragms, stiffeners in the longitudinal, transverse, as well as along the depth of the directions also there. To understand that itself is very complex. The thickness of the plates were varying from 80 mm to 250 mm in case of the pylon base. In case of the tie beam, which is connecting the two pylon base the thickness was varying from 25 mm to 120 mm, as you can see here, where the pylon kink is there, kink element, the understanding the geometry and the complexity of the fabrication to be involved was very, very difficult. Without BIM model or the Tekla model, it would not have been possible for us to understand how the anchorage assemblies inside this particular case at the level of the kink. Even the thickness of the plate for this kink assembly was also around varying from 10 mm to 100 mm thickness. And as I explained to you at the location of the P123, especially where the anchorages houses were getting connected to this P23 rocker pendulum bearing, the understanding of to understand that the Tekla model was very useful. As you can see here, the thicknesses of plate were varying from 20 mm to 120 mm, as you can see here. In the backstay anchorages, again another complexity, as you can see here, without Tekla as well as the BIM model, perhaps it would not have been possible to understand and fabricate properly this complex structure, as you can see here. Even the anchorage assembly at the deck level, to understand that and to fabricate it precisely to that inclination, as well as the pylons, the inclination of this anchorage deck assembly was varying from one cable to the another cable. To understanding of that and to make sure that the various thicknesses, and to make sure that the fabrication as well as the trial assembly of this is done properly, the Tekla model as well as the BIM model was very, very important. Even from the point of view of the logistics and the transportability, the redesigning of the splices has to be done. As you can see here in the original design, this was the size of the pylon base which was given, and it just was weighing around 560 ton, and the size was also around 10.5 meter in the vertical direction, as well as 11.5 meter in the transverse, and longitudinal direction 8.5 meter. It was not possible to transport and handle, and also the fabrication and the trial assembly complexities it was imposing. In view of this, it was to be exploded. It was to be subdivided into further segments, as you can see here. This L0 segment as well as the L1 segment, which I'm going to explain later, was separated out from the transportability as well as the handling and fabricability point of view. The deck fabrication, as I told you, explained to you, was done in China, ZTSS, and that was because 80 mm and above thick plates were not available, and the fabrication fabricators of up to 250 mm thick plates was not also available in India at that particular point of time. And for the purpose of the fabrication, the deck was divided into 37 segments. There were 3 standard segments as well as remaining the non-standard segments. Each segment was having a cross girder, as you can see here, the longitudinal girder and the central girder. The central girder was made up of eye connecting unit, as you can see here, longitudinal central girder component. It's an eye girder, as you can see here. All kinds of equipments were used for the purpose of this complex fabrication, whether it's a magnetic crane for handling of the cut sheets, so that the deformation of the plates doesn't take place, CNC flame cutting machine, edge milling machine, CNC plane drilling machine, CNC underwater plasma cutting machine, CNC multi-head straight line machine, CNC 3D drilling machine, and I-beam production line. Whatever the possible equipments, the latest technology was available, was used for the fabrication as well as the trial assembly for both girder fabrications as well as the pylons fabrication. These are some of the views of how the pylon, the cross girder fabrication was done in the fabrication yard or the fabrication factory in ZTSS Jiangyin, China. As you can see here, these are some of the views over here. I'll just, due to the paucity of the time, otherwise I'll not be able to complete it. I'm just going to run through. There was a special I-beam line was also used. And after having done the fabrication, all kinds of tests, whether it's a dye penetration test, ultra magnetic testing, all this NDT testing was done. Testing of the welds were done, ultra violet testing, everything was done. as you can see here. And these are some of the views of even the splice plate, was fabricated, and wherever it is required, the machining was done. Since even the girder within the cables, which I'm going to explain you later, and the machining surfaces were used. Machining surface, it is not the compression forces even in the cross girder, the longitudinal girders was not taken by, it was a full contact compression joints were used. So the proper machining was required to be done in the longitudinal girder, and the splice plate has to be the drilled with the drilling machine. As you can see here, some of the views of the drilling, the machining, as well as the splice plate preparations views you can see over here. And finally, the trial assembly was to be done. In the trial assembly is very, very important from the point of view of since the compression joint has been extensively used even for the composite girder connections over here, composite girder connections over here, and the trial assembly was done. Minimum 5 segments were used for the trial assembly, including the anchorage boxes over here, as you can see here. Trial assembly is a very, very important part of the fabrication, especially when the fabrication is done somewhere else, brought to the location, again assembled and erected. If the fabrication trial assembly is not done at the location where the fabrication is done, the fabricated components which is brought to the site, which is it may not fit into each other. To avoid that, the trial assembly is a must for such complex this one. During the fabrication of the girder itself, as you can see here, that the stud welding studs were welded. For using the studs welding, the stud guns were extensively used. And as you can see here, once it is done, the painting, after having applied the primer zinc oxide, and the exonable paint was used, and the painting also was done under the environmentally controlled conditions. After having done the painting with the exonable paint, as you can see here on the right side, it was mounted on the barge, and it is ready for transportation to India, as you can see here from China. Pylon fabrication was more complex compared to that of the deck fabrication due to its owing to its complex geometry, three-dimensionally complex geometry. And for the purpose of the fabrication, it was divided into the various segments, as you can see here. Pylon leg was divided into L0 segment to that of L11 segment, L10 segment, as you can see here. And again, each segment was having the 2 blocks which was connected with each other. And the pylon body also was converted into, or for the purpose of fabrication, as well as the trial assembly, divided into the 5 units, MB1 to MB5. And again, in the transverse direction, it had the rear segments as well as the front segment, and it was given the different designations, or the as you can see over here, for the purpose of identification and the ease of fabrication. As I told you earlier, that the most of the pylons were done in segmental fabrication, and it had around 36 joints, as you can see here. These 36 joints was to be machined, and one of the conditions to the contractor was to have a machining or a milling machine which can do the machining at one go of 36 meter length. At around location of the pylon king, the length of the segments was around 36 meter, and the subcontractor had to have the capacity to do the machining of 36 meter length at one go. And that was one of the reasons it was, one of the reasons this job was handed over to ZTSS, as they promised that they would be able to purchase the machining, milling machine, which can do the machining of 36 meter length at one go, and machining and drilling of the bottom face, and the machining and drilling of the top face. So there was around almost 36 faces to be machined in this particular thing. Most important thing is this particular pylon has to transfer the huge compression force to the foundation, and that is the reason always this compression force has to be transferred to this compression joint. What we call it is a butt joint and abutting each other. And that's very, very important to the compression joint. And the precision of this machining is very, very important over here. These are some of the views of the fabrications of the pylon kink portion, as you can see here. Also the pylon leg. This is the paneling. This is the internal diaphragm, the fit out. And after having done the fit out, that internal diaphragms, which may be of that of bracing kind, or the stiffness, the longitudinal stiffness as well as the transfer stiffness, the views which was to be meticulously planned and the fabrication has to be done. This is the pylon kink location and also the pylon leg, the fabrication which is going on over here. This is the intermediate stage where the pylon fabrication is going on. The base pylon base fabrication was a very, very Herculean task. As I told you, the pylon base was weighing around 450 tons. It was a very complex crisscrossing the internal diaphragms arrangement, as you can see here. And the 250 mm thick plate was to be cut. It was having the thickness of the plates from 80 mm to 250 mm. And this pylon base, while fabrication has to be rotated or made upside down, as the overhead welding was totally prohibited. Always the side welding or the bottom welding was encouraged over here. Overhead welding was totally prohibited. In view of that, after having done the welding of the bottom plate, say for example, after having done the stiffener welding, to do the welding at the top, it has to be rotated upside down. It has to be turned upside down. 450 ton, this one has to be done. And these are some of the views of here, cutting of the 250 mm thick bottom plate, as you can see here. It is a Herculean task. You can see here the internal as well as the external diaphragms being welded over here, of the thicknesses of the plate varying from 80 mm to even the 250 mm. These are the thicknesses of the plate, 120 mm thick plate, as you can see. The crisscrossing diaphragms as well as the stiffness was causing a lot of problems for the fabrications. The fabrication was very, very complex. And during the fabrication, a lot of heat used to be generated, and we'll have to have an environment, the cooled environment, so that it takes place. A very complex fabrication which was to be done. After having done the fabrication, the machining was to be done. At this particular location, the machining equipment was there. That is the reason it was to be taken to some other location. It was barge mounted crane. Along with this barge mounted crane, it was to be transported to some other nearby city where the machining arrangement was done and the machining was done, as you can see here. These are some of the views of the pylon base which was fabricated, being handled at the fabrication factory. As I explained to you, that the machining is very, very important part of this, and the large areas was to be machined, and special machining equipment was to be brought, and the fabricator purchased the special machining equipment which can machine up to 36 meter length. As I can see, these are some of the views of the machining. And even for doing the machining, extensive BIM building information modeling techniques were used in the form of the application programming interface, the theodolite or the total station surveying, and also to control the vibration during the machining of these large segments. The temporary stiffness were used. Special jigs were to be designed so that it doesn't subsidence doesn't take place, as well as the deformation in the machined segment will not take place. So the BIM even was used for the purpose of that. Trial assembly is very, very important part of this kind of steel structure construction, basically because if the fabrication is done somewhere in the other country like China, this fabrication which has been done in China has been brought to the India. At the site, these fabricated segments have to be erected, as you can see here. For any reason, if the perfect matching between these two segments has not been ensured, even a small inclination difference or small deformation in this machine surfaces may lead to the pylon in the final analysis as can be shown in this particular diagram over here. This is similar to that of the precast segmental construction, where the precast segments are not cast properly, because if there are deformities or deformations which is not match cast properly between the two segments, if there is a deformation in the form of proper improper casting of the segment, the small inclination which has been introduced because of the improper casting of the segment finally may lead to this the geometry like this in the precast segmental construction. It is similar to that of this. The match casting has to be done completely. The machining has to be done, and the trial assembly, including 3 to 4 segments, has to be done together, so that there is no the fabrication has been done exactly to the requirement of the design. For the purpose of trial assembly, as I told you, this is divided into the so many segments. This is a leg segment, and entire the king trial assembly of L6 to L10 has been done once. And for trial assembly of the subsequent segment, always the previous segment, which was a part of the previous trial assembly, has to be used as a reference segment, and it has to be ensured to the proper geometry. If there is any deviation is observed during the trial assembly, the correction has to be made at that particular point of time itself. These are some of the views of the trial assembly. The trial assembly of the legs can be done vertically, as you can see over here. It was not a very difficult task. Only the thing is we had to engage the heavy lifting arrangements like the cranes and other things. As you can see here, these are some of the views of the trial assemblies of the king portion as well as the pylon body portions, as you can see here. Even the anchorages were to be, these are the anchorages in the pylon body, as you can see here. This has to be fabricated to the precision, so that the inclination of the anchorages, which has been embedded into the pylon body, as well as at the deck top of the deck, is perfect. That was ensured, and we had engaged the supervisory team from India, so that the perfect supervision has been done for the fabrication which has been done in China. Even the temporary structure arrangement, like this temporary structure arrangement, as you can see over here, it's a temporary supporting structure. This temporary supporting structure also was fabricated as well as the trial assembled at the China Jiangjing fabrication factory, and it was supervised by our people to the precision before being shipped to the India. Finally, this fabricated segment were to be shipped to the India. This is the route which has been followed, as you can see here. The specially assigned ships were engaged, in the sense all the segments were to be brought under the deck, so that they are not exposed to the environmental condition. And also the ships should be having the cranes equipped with the crane which can handle the capacity of 450 ton capacity segment. The pylon base was weighing around 450 ton, and it took almost 30 days for transportation of this pylon as well as the deck segments. One consignment almost took around 30 days. The route followed was from Shanghai to the bottommost tip of India, to that of Kandla port. Once it came to the Kandla port, these are some of the views before coming to the Kandla port. These are some of the views of the very heavy segment of around 450 ton pylon base, along with jig. Jig was also attached while being transported from China to India, so that the pylon base segment is not deformed, as you can see here. And this is being loaded to the ship, as you can see here. Then once it reaches the Kandla port, from the Kandla port, it has to be transported around 1,590 kilometers to the Vajirabad, our site. And while transporting, it has to be ensured that the pylon base segment was the heaviest segment, as you can see here, 450 ton. And also the longest segment was the cross girder. That was around 30.2 meter length cross girder, which was a tie girder, which was connecting the pylon base, which was to be done. Before transporting it, the transporter did the route survey extensively for 2 months to make sure that all the culverts as well as the bridges can take the load of 450 ton. And the route survey was done. It was identified that the 25 locations, it was not possible for us to take this pylon base on top of the existing culverts as well as the bridges. That is why the special the bunds or the roads, temporary roads were constructed along with just beside these bridges. And this the temporary bridges, temporary bund was to be maintained so that it is the pylon bases and the other segments could be transported on this temporary bunds before the monsoon has been set in. If the monsoon has come, this temporary roads would have been washed up. So it was a meticulous planning was required so that the temporary roads were constructed, and also the transportation of the segments from China. Shipment has arrived to India in time so that the temporary construction at 25 locations is not encountering the monsoon, thereby the fear of washing up this temporary bunds or the temporary roads. Finally, the pylon base, as you can see here, after crossing this the barrage bridge in Wajirabad has reached the site, and we were doing the calculations whether the barrage bridge and other bridges along this along this river Yamuna can take this pylon base. But earlier, the transporter had transported the similar boiler after weighing around 450 ton on this temporary bridge, on the barrage bridge. That's why he was confident that this bridge would be able to take this load of 450 ton. And finally, it was transported to the location, at the site location at Wajirabad for the being erected. The erection was required a meticulous planning. It was of its kind, and it was not done and the time-tested erection for this kind of peculiar Namaste post, three-dimensionally varying asymmetrical pylon. It was a prefabricated segmental erection. And how to erect the bridge using the method statement, and it was consisting of the temporary construction structures and reinforcement. The internal structure temporary has to be done, and it was also involving the rigging plans, which was to be meticulously arranged. And during the construction control, because exactly as per the plan, the erection doesn't go on, deformation takes place, and that has to be checked, and the calculations has to be done, structural checking has to be done, and all these things was to be done. And the construction stage analysis was meticulously done. After having done the construction stage analysis, wherever it's required, the temporary strengthening of the structure was done. Just to give an example, just to give the kind of planning which was going into that, there were 300 method statements were written for the erection of the pylon itself. And in this 300 method statement, this is one of the method statements which I'm going to explain for the purpose of the erection of this tie beam between the pylon base. This is the pylon base, as well as this is the pylon base, and in between the tie beam has to be erected. As you can see here, the method statement was to be completely prepared. After having erected, as you can see here, this was assembled at the bottom, and after having assembled using the crane, this assembled at the bottom was erected on top of this trestle over here. And once this is erected on top of this trestle, around 160 tons of the vertical force has to be induced by the operation of the jacks, which has been put on top of this trestle. So over here, this reaction was required to be given, so that once this support is removed over here, it gives to this original geometry, the design geometry. That's how this 160 10 the jacks forces was to be given here. This is just an example how meticulously the rigging plan as well was written in the form of the method statement, as you can see here. This is the erection of this one. After having done the various alternative, examined and explored the various alternatives, it was decided that on the reverse side, the pylon the deck erections will be taking place by way of the operation of this the Goliath gantry on top of the temporary bridge which has been constructed over here. On the land side, this can have been erected, this girders as well as the precast panels, which I'm going to explain later, could be erected using the crane itself. Not this crane, we had another crane for the erection of this one. And the pylon erection, after having alternatively decided to have the 1,250 ton capacity, the crane, as well as the tower crane, which has been attached to the pylon, could be used. That was analyzed and it was adopted. And you can see some of the views of the cross girders which have been erected on top of the temporary trusses, which has been shown over here. This is a temporary trusses, and you can see the pylon deck being erected, the deck girders being erected using the overhead gantry, or the Goliath gantry, what we call it as, which is run on the gantry cranes supported on temporary trusses over here. These are some of the views here. These are the trusses views. Even in the river also the trusses were erected, and these trusses were called temporary foundations were done over here. And you can see this axis which has been shown over here from 3 to 4 to 18, where the temporary structure, temporary pile foundation which has been provided for the erection of this girder. The precast panels was used for the RCC composite deck construction. On this already erected cross girders as well as the longitudinal girders, the precast panels of size of around 8 meters to 4.5 meters. Of course, the sizes varies depending upon the location of this precast panels, weighing around 330 ton. And these were precast panels were cast. These are some of the views of cast in situ joint, how it is jointed using the location. This is the embedment of the steel plate which has been provided in the precast panel, so that this precast panel can be supported on the already erected girder over here. And here it's a sort of a, like a stopper to support this precast panel. You can see here it was specially designed. Some sort of a loop joints were provided over here in the form of reinforcement loops over here. These are some of the views where it is a precast panel casting yard, where you can see all the activity of the casting, the shuttering, as well as the curing, and also the stacking of this one precast panels, along with the Goliath gantry or the bed gantry for handling of the precast panel of 30 ton. Once these precast panels were cast, brought on top of the already cast deck, and demotorized trolley was used for the transportation of the precast panels over here. Once this is put into position, the cast in situ sink-free concreting was done to ensure the monolithic connections was assured between the two panels which was there. The various alternatives was examined for the purpose of the erection of the superstructure, as you can see here, and temporary supporting conditions was on the basis of the temporary supports, as well as the 1,250 ton capacity crane, and also the telescoping the tower crane which has been attached to the pylon. As the pylon grows, with the proper connection to that was chosen as the appropriate method of erection for this pylon. These are some of the views of the pylon. You can see that the pylon legs being erected over here, and the most important things for the erection of the pylon was this a temporary structure support which has been given, which has been equipped with many of the jacks at the end over here, so that if there is any deformation, to achieve the required geometry, the jacks can be used, horizontal jacks as well as the vertical jacks. The vertical jacks have been provided attached to this temporary supporting structure over here for adjusting the geometry of the pylon as it goes on being erected, as you can see here. During the erection, there was a tie-down system. This tie-down system was used up to the erection of the legs, up to the L5 legs. And this tie-down was constructed, housing the tie-down. There was a foundation over here, which was housing, which could house the anchorages for 31 to 15 cables, as you can see over here. And by the operation of this temporary pre-stressing cables, which was anchored in the foundation as a tie down, by operation, the maximum force which was applied on this temporary tie down system was around 690 ton. When the L5 segment was erected on top of that, by the time of the erection of the L7 segment, this temporary tie down system was relieved and dismantled, and the entire load was transferred to this temporary supporting system, as you can see here. The most important and the crucial, the unsung hero of this project is 3D turntable, which has been specially designed. Without this, I don't think this erection of the pylon would have been possible. This was very ingeniously designed, as you can see here. This can enable the rotation in the longitudinal direction, as well as the transverse direction over here, as you can see here. And while the pylon segments, which has been assembled on top of this 3D turntable or the jig, what I call it as here, which has been used on top of this, at the time of takeoff, being connected to this by the crane here, this the geometry of this segment has been adjusted in such a way by the operation of the longitudinal rotation arrangement, as well as the transfer rotation arrangement, and the slings which has been attached to the crane in such a way this segment can be directly taken off and vertically taken off and put on top of already placed segment completely on top of that vertically down. And the rigging plan has to be very meticulously planned in the method statement, which I explained, 300 number of method statement which has been done. The meticulous calculations have to be done. As you can see here, the calculations has to be done in such a way that the CG of this segment in the lifted position should travel through the hook, the vertical hook over here, so that segment is stable while being erected using 1,250 ton crane. So this turntable is the key for the key factor for the successful erection of this project. These are some of the views, as you can see here. This is at the time of the takeoff position. This is at the time of landing the segment using this crane, as you can see here. And this has been adjusted perfectly to the orientation, so that it can be vertically take off using this crane and vertically put on top of already put the segment over here. That's how the segmental erection, prefabricated segmental erection has been done. As the segment went on being erected, the pylon grew in stature, as you can see here. The pylon legs merged at the locations. Once the pylon legs merged, we were very confident that the pylon is growing as has been planned, and the fabrication as well as the trial assembly which was carried in China was perfect. This erection was done completely in-house through the in-house engineering at that particular point of time. Here is the location where the pylon is merging. After the pylon is merged, you can see that the pylon is growing by the segmental prefabricated erection. This is a temporary tower crane which has been attached to the pylon as it goes on. And due to the sun's movement from one direction to the another direction, pylon legs, before being merged as a body later, were moving drastically, as you can see here. And the monitoring of this movement was done, and the pylon legs, the temporary supports was to be fixed in such a way in a particular time where the pylon legs were moved so that the temporary locations geometry is perfectly matching with that geometry of that. One end of the temporary support was fixed earlier, and during the daytime, it was allowed to move as it perfectly, and the other end was made to slide. And this sliding end, when it reaches, the pylon has moved to the location where the geometry was matching. The bolting of that, the other end, which is a sliding end, was done. Even after the merging of the pylon at the body location, as you can see here, the pylons were moving from daytime to the evening time, almost in the longitudinal direction of around 40 mm, and in the transfer direction of around 25 mm. So this was to be perfectly monitored, and this environmental deformation of the pylon during the due to the temperature variation has to be taken into consideration while erecting the pylon, apart from the deformation which normally takes place because of the loadings, which as well as this pre-stressing. Even the pylon facade or the viewing gallery, what we are talking about, as you can see here, which is quite huge, which has been equipped with many platforms inside. As you can see here, it's a skeleton or the structural frame of the viewing gallery, which is later to be embedded with the glass facade. As you can see here, this was also fabricated at China, and the trial assembly was done, brought to the location, and has been erected, as you can see here. Once this has been erected into position, the glass, the facade of the glasses were taken on top of that, and with the precisely designed methodology, the glasses were attached to this viewing gallery, as you can see here. These are some of the views as the pylon grew in stature. You can have a look at it, and these are the different views. And even during the construction, it was looking majestic, as you can see here. And these are some of the views which have been taken using the drones during the construction. You can also see the barrage bridge, which was always perennially congested for the traffickers, which was made easier later for the onlookers later. And these are some of the accessories, arrangement, pylon access arrangement, as you can see here. And this is the pylon access arrangement, the cage ladders, as well as the temporary platforms, which was fitted with. And also most importantly, this tower crane, telescopically adjustable, telescopically extendable tower crane. As the pylon grows, it had to be, a special connection has to be designed between the tower crane as well as the pylon as the pylon grew, so that the forces either from the pylon to the temporary cranes or from the temporary crane to the pylons is not induced, which are unscheduled forces are not induced to each other, damaging the pylon or the temporary cranes. And the temporary crane, the tower crane, also was equipped with the passenger hoist for the transportation of the laborers, as well as the jacks and other materials which was required at the at the pylon grew later, as it is not possible to always to send the laborers as well as the other materials to the cage ladder, which has been connected to these platforms over here. The peacock graphs were painted on top of the pylon segments during the erection, as you can see here, within the temporary shed which has been constructed constructed at the site itself. This is a 3D turntable. You can see the temporary platform which has been attached to the segment, and the peacock graphs were embedded on the segments in the grid method, using the grid method. And while making the payment, the painting, it was ensured by application of the negative 3M masking tape, that the 3M masking tape, after having done the painting, is removed so that the painting is not spilled over, and the painting is within the peacock graphs representation, as you can see here. Finally, befitting to this stature of this particular bridge, the bridge was inaugurated with the grand fanfare emotional speeches by Manish Sisodia as well as Kejriwal, the Chief Minister of Delhi, and also the exciting laser show on 4th November 2019 to the public. At the time of the commissioning of this bridge, it is to be noted that still the temporary tower crane which was attached to the pylon was there. It was necessary because the glass facade was erect. The glasses which was to be attached to this frame was not completed, but the bridge was a need of the hour at that particular point of time. The glass facade was done later after the commissioning of the bridge or the inauguration of the bridge in November 2019. In my opinion, some of the accessories which has been used, that is 1,250 ton serene crane, 3D turntable, a 36-meter long machinable milling machine, a temporary supporting arrangement designed by Miranda, as well as the RCD rig, which was used for construction of the hybrid bed, hybrid foundation will be the unsung heroes of this particular signature bridge of its once in a lifetime kind, because these are not going to be seen anymore, where the signature bridge is going to be there, standing aplomb for many accolades, as well as the recognitions which is going to be given and which is going to be appreciated by the onlookers for years to come in the future. This particular bridge had to be administered, or the management of this bridge had to be done in a manner which is not done anywhere, which is not taught in any business schools, in my opinion, because the 9 to 10 countries were involved in this bridge. And we used to have a stakeholders meeting. I think at least 10 or 12 stakeholders meeting we had were involving all the stakeholders. And also on the day of the commissioning of the bridge, I think perhaps this is a photograph which has been taken, which we have celebrated over here. You can see here. And I would like to contribute this bridge. It would not have been possible perhaps for some of the very important contribution. One is from the Slice Bagaman and partner, Matthias Widemeyer. It was contribution for the fabrication as well as the erection is immense. And also the construction engineer, which was done by Dr. Di Miranda from Italy, and who prepared the method statement for the erection in the form of the 300 number of drawings with the erection. 3D turntable was also designed by him, and it was fantastic, I thought. And also you can see some of the important contributors here, Mike Slice, the designer of the bridge, and the architect, Mr. Ratan Botley Boy, who made this bridge look so beautiful. I am particularly very grateful to this bridge because after having been involved from the inception to commissioning of this bridge, I had an opportunity to give a very prestigious Padma Bhushan Professor Jayakrishna Memorial lecture. I don't think with this, the popularity of this bridge made this organizers to call me for giving this particular lecture. I don't think without this bridge, I would have been invited to give this privilege and honor of delivering this particular bridge. And this particular bridge, during this construction of this bridge, I also happened to devise my own model of the model of 4 determinants of the conceptual design, as you can see here. And it was also possible only because of this bridge to me. This I could form this model of 4 determinants of conceptual design of the structures because of this particular bridge. So I am particularly very grateful to this bridge. And thank you very much for giving me an opportunity for delivering this this very honorable honor of delivering this prestigious lecture. Thank you very much, and I would like to hand over this virtual dais to the organizers. Thank you. I think you are mute. You're mute, I think. I don't know. He's not.
Chairman, sir, can you hear me?
Lighting our knowledge pertaining to significantly starting from foundation with all details of design and technical parameter. Again,
Sir, your audio is not clear.
Thanks for Bhutan Professor Jai Krishna Memorial Lecture, and again a special thanks for enlightening our knowledge pertaining to significantly with detailed technical and design parameters starting from foundation, substructure, and superstructures. Thank you.
On behalf of the Institution of Engineers India, I thank Engineer V.N. Hegde, Chief Executive Officer, Stoop Consultant Private Limited, for delivering the prestigious Padma Bhushan Joy Krishna Memorial Lecture. So we thank you very much for your enlightening lecture. After this memorial lecture session, we shall commence the technical session 1 after 15 minutes. So at now it is 3:05. So we shall start our technical session at 3:20 p.m. We would request all the participants of the technical session to be online, and we shall commence the session at 3:20 p.m. Thank you.
Thank you. Thank you very much. And thank you for inviting me.
No.
Okay, sir.